So apparently data is the new oil. And if that's the case, let's learn how we can control that data and store it ourselves and then refine it ourselves. Now, what I really mean here is we're going to be building out an analytics API service so that we can ingest a lot of data. We can store a lot of data into our database that changes over time, or time series data. The way we're going to be doing this is with FastAPI as our microservice. This is going to be our API endpoint that has, well, mostly just one data model that we're going to be ingesting. From there, we're going to be using, of course, Python to make that happen. That's what FastAPI is built in. But we're going to be storing this data into a Postgres database that's optimized for time series called Timescale. I did partner with them on this course, so thanks for that, Timescale. But the idea here is we want to be able to keep track of time series data. Timescale is optimized Postgres for time series data. It's really great. I think you're going to like it. Now, we're also going to be using Docker in here to make sure that our application is containerized so we can deploy it anywhere we want, and we can use the open source version of Timescale to really hone in exactly what it is that we're trying to build out before we go into production, which absolutely we will be. Now, the idea here is once we have it all containerized, we'll then go ahead and deploy it onto a containerized cloud called Railway, which will allow us to have a Jupyter Notebook server that can connect to our private API endpoint, our private analytics server altogether. Now, all of this code is open source, and I did say it's done in FastAPI, which really means that we're going to be writing some fairly straightforward Python functions that will handle all of the API endpoints and all that. The thing that will start to get a little bit more advanced is when we do the data modeling, and specifically when we do the querying on the data modeling. Now, these things I think are really, really fascinating, but I ease you into them. So I go step by step to make sure that all of this is working. Now, I do want to show you a demo as to what we end up building at the end of the day. We got a quick glance at it right here, but I want to go into it a little bit more in depth. Now, I do hope that you jump around, especially if you know this stuff already. And if you come from the Django world, the models that we're going to be building, I think are a little bit easier to work with than Django models. There's less to remember because they're based in Pydantic, which is what SQLModel is based in as well, which allows you to write just really simple models. It's really cool. It's really nice to do. So those of you who are from Django, this part will be very straightforward. FastAPI itself is also very straightforward and a really, really popular tool to build all of this out. Now, the nice thing about all of this is all the code is open source, so you can always just grab it and run with it and deploy your own analytics API whenever you want to. That's kind of the point. So if you have any questions, let me know. My name is Justin Mitchell. I'm going to be taking you through this one step by step, and I really encourage you to bounce around if you already know some of these things. And if you don't, take your time, rewatch sections if you have to. Some of us have to, and that's totally okay. I know I had to repeat these sections many times to get it right. So hopefully it's a good one for you, and thanks for watching. Look forward to seeing you in the course. The point of this course is to create an analytics API microservice. We're going to be using FastAPI so that we can take in a bunch of web traffic data on our other services, and then we'll be able to analyze them as we see fit. And we'll be able to do this with a lot of modern technology, Postgres, and also specifically Timescale, so we can bucket data together and do aggregations together. Let's take a look at what that means. Now, first and foremost, at the very end, we are going to deploy this into production, and then we will have a Jupyter Notebook server that will actually access our private analytics API service. This is completely private, as in nobody can access it from the outside world. It's just going to be accessible from the resources we deem should be accessible to it, which is what you're seeing right here. Once we actually have it deployed internally and private, we can send a bunch of fake data, which is what's happening. This is pretending to be real web events that will then be sent back to our API, as you see here. So this is the raw data. So from this raw data, we will be able to aggregate this data and put it into a bulk form that we can then analyze. Now, of course, this is just about doing the API part. We're not going to actually visualize any of this just yet, but we will see that if I do a call like duration 2 hours, I can see all of the aggregated data for those 2 hours. Now, this becomes a lot more obvious if we were to do something like an entire month and we can actually see month over month data that's changing. But in our case, we don't have that much data. It's not really about how much data we have. It's much more about how to actually get to the point where we can aggregate the data based off of time series. That is exactly what Timescale does really well and enhances Postgres in that way. So if we actually take a look at the code itself, of course, is open source. Feel free to use it right now. You can actually come into the SRC here, into the API, into events, into models. You can see the data model that we're using. If you've used SQLModel before, this will actually give you a sense as to what's going on. It's just slightly different because it's optimized for time series and timescale, which is what TimescaleModel is doing. Now, if you've used Django before, this is a lot like a Django model. It's just slightly different by using SQLModel and something called Pydantic. Don't worry, I go through all of that and you can skip around if you already know these things. But the point here is that is the model we are going to be building to ingest a lot of data. After we have that model, we're going to be able to aggregate data based off of all of that, which is what's happening here. Now, this is definitely a little bit more advanced of an aggregation than you might do out of the gates, but once you actually learn how to do it, or once you have the data to do it, you will be able to have much more complex aggregations that will allow you to do really complex, averaging or counting or grouping of your data. All of it is going to be done in time series, which is, I think, pretty cool. Now, when we actually get this going, you will have a fully production-ready API endpoint that you can then start ingesting data from your web services. I think it's pretty exciting. Let's go ahead and take a look at all of the different tools we will use to get to this point. Let's talk about some of the tools we're going to use to build out our analytics API. First and foremost, we're going to be using the FastAPI web framework, which is written in Python. Now, if you've never seen FastAPI before, it's a really great framework to incrementally add things that you need when you need them. So it's really minimal is the point. So there's not a whole lot of batteries included, which gives us all kinds of flexibility and of course makes it fast. So if you take a look at the example here, you can see how quick we can spin up our own API. That's this right here. This right here is not a very powerful API yet, but this is a fully functioning one. And of course, if you know Python, you can look at these things and say, hey, those are just a few functions. And of course, I could do a lot more with that. That's kind of the key here that we're going to be building on top of. Now, if you have built out websites before, or you've worked with API services before, you can see how easy it is to also do the URL routing. Of course, we're going to go into all of this stuff in the very close future. Now, of course, we're going to be using Python and specifically Python 3. The latest version is 3.13. You can use that 3.13, 3.14. You could probably even use 3.10, maybe even 3.8. I'm going to most likely be using 3.12 or 1.3, but the idea here is we want to use Python because that's a dependency of FastAPI. No surprises there, probably. Now, we're also going to be using Docker. Now, I use Docker on almost all of my projects for a couple of reasons. One, Docker locally emulates a deployed production environment. It does it really, really well, and you can actually see this really soon. But also, we want to build our applications to be production ready as soon as we possibly can. Docker really helps make that happen. Now, another reason to use Docker is for database services. So if you just want a database to run on a per project basis, Docker makes this process really easy. And so, of course, we want to use a production-ready database, and we also want to use one that works with FastAPI and that is geared towards analytics. Lo and behold, we're going to be using Timescale. Timescale is a Postgres database, so it's still Postgres SQL, but it's optimized for time series. Now, yeah, I partnered with them on this series, but the point here is we're going to be building out really rich, robust time series data and full-on analytics, right? That's the point here. We want to actually be able to have our own analytics and control everything. So initially, we're going to be using Docker or the Dockerized open source version of Timescale so that we can get this going. Then as we start to go into production, we'll probably use more robust services from Timescale directly. Now, we're also going to be using the Cursor code editor. This, of course, is a lot like VS Code. I am not going to be using the AI stuff in this one, but I use Cursor all of the time now. It is my daily driver for all of my code. So I am going to use that one in this as well. Now, I also created a package for this series, the TimescaleDB Python package. so that we can actually really easily use FastAPI and something called SQLModel inside of our FastAPI application with the time series optimized TimescaleDB. That's kind of the point. So that's another thing that I just created for this series, as well as anything in the future. That, of course, is on my private GitHub. As far as the Coding for Entrepreneurs GitHub, all of the code for this series, everything you're going to be learning from, is going to be on my GitHub as well, which you can see both of those things linked in the description. So that's some of the fundamentals of the tooling that we're going to be using. Let's go ahead and actually start the process of setting up our environment. In this section, we're going to set up our local development environment, and we want it to match a production or a deployed environment as closely as possible. So to do this, we're going to download and install Python 3. We're going to create a virtual environment for Python projects so that they can be isolated from one another. In other words, Python versions don't conflict with each other on a per project basis. Then we're going to go ahead and do our FastAPI Hello World by installing Python packages. And then, of course, we're going to implement Docker Desktop and Docker Compose, which will allow for us to spin up our own database, that Postgres database that we talked about previously. And of course, it's going to be the Timescale version, the open source version of that. Once we have our database ready, then we'll go ahead and take a look at a Dockerfile for just our FastAPI web application so that that can also be added into Docker Compose. And again, being really ready to go into production, then we'll take a look at the Docker-based FastAPI Hello World. Now, all of this you could skip, absolutely, but setting up an environment that you can then repeat on other systems, whether it's for development or for production, I think is a critical step to make sure that you can actually build something real that you deploy for real and get a lot of value out of it. So this section, I think, is optional for those of you who have gone through all of this before, but if you haven't, I'm going to take you through each step and really give you some of the fundamentals of how all of this works, just to make sure that we're all on the same page before we move to a little bit more advanced stuff and advanced features. So let's go ahead and jump in to downloading and installing Python 3 right now. We're now going to download and install Python, and specifically Python 3.13 or 3.13. Now, the way we're going to do this is from python.org. You're going to go under downloads, and you're going to select the download that shows up for your platform. Now, there are also the platforms shown on the side here, so you can always select one of those platforms and look for the exact version that we're using, which in my case, it's Python 3.13, and you can see there's other versions of that already available that you can download with. Now, this is true on Windows as well, but the idea is you want to grab the universal installer for whatever platform you're using. That's probably going to be the best one for you. This isn't always true for older versions of Python, but for newer ones, this is probably great. So we're going to go ahead and download that one right there. And of course, if you are on Windows, you go into Windows and you can see there's a bunch of different options here. So pick the one that's best for your system. Now, if you want a lot more details for those of you who are Windows users, consider checking out my course on cross-platform Python setup because I go into a lot more detail there. Now, the process, though, of installing Python is really straightforward. You download it like we just did. This is true for Windows or Mac. And then you open up the installer that you end up downloading, and then you just go through the install process. Now, one of the things that is important that it does say a number of times is use the install certificates. We'll do that as well, just to make sure that all of the security stuff is in there as well. So I'm going to go ahead and agree to this installation. I'm going to go ahead and run it. I'm going to put my password in. I'm going to do all of those things as you would with installing any sort of software from the internet. Now, I will say there is one other aspect of this that I will do sort of again, in the sense that I will install Python again using Docker, and specifically in Docker Hub. So yeah, there's a lot of different ways on how you can install Python and use it, but both of these ways are fairly straightforward. Okay, so it actually finished installing, as we see here, and it also opened up the Finder window for me for that version. If you're on Windows, it may open this folder, it might not. I haven't done it in a little while, but the idea is you want to make sure that you do run this installation command here, which, if you look at it, is really just running this pip install command. We'll see pip installing in just a moment, but that's actually pretty cool. So we've got pip installs, the certificate command basically to make sure all that security is in there. Now, once you install it, we just want to verify that it's installed by opening up another terminal window here and run something like Python 3-V. Now, if you see a different version of Python here, there's a good chance that you have another version already installed. So for example, I have Python 3.12 installed as well. You can use many different versions of Python itself. All of these different versions are exactly why we use something called a virtual environment to isolate Python packages. Again, if you want a lot more detail on this one, go through that course. It goes into a lot more detail on all different kinds of platforms. So consider that if you like. Otherwise, let's go ahead and start the process of creating a virtual environment on our local machine with what we've got right here. Part of the reason I showed you the different versions of Python was really to highlight the fact that versions matter and they might make a big issue for you if you don't isolate them correctly. So in the case of version 3.12 versus 3.13 of Python, there's not going to be that much changes in terms of your code. But what might have a major change is the third-party packages that go in there. Like, what if FastAPI decides to drop support for Python 3.12 and then you can't use that anymore? That's kind of the idea here. And so we need to create a virtual environment to make that happen, which is exactly what we talked about before. So back into Cursor, we're going to go ahead and open up a new window. Inside of this window, we're going to go ahead and open up a new project. So I want to store my projects in here. So I open up a new project. I find a place on my local machine as to where I'm going to store it. And we're going to call this the Analytics API, just like that. And I'll go ahead and open up this folder. Okay, so normally with Cursor, it's going to open you up to the agent. I'm not going to use the agent right now. I'm just going to be using just standard code. And we're going to go ahead and first off, save the workspace as the Analytics API. We'll save it just like that. Then I'm going to go ahead and open up the terminal window, which you can do by going to the drop down here, or if you learn the shortcut, which I recommend you do, it can toggle it just like I'm doing. Okay, so the idea here is we want to just, of course, verify that we have got Python 3 in there. You can probably even see where that version of Python 3 is stored. This actually shouldn't be that different than what you may have saw when we installed these certificates here. But the idea, of course, is we're going to use this to activate our virtual environment. So I'm going to go ahead and do Python 3.12, or rather Python 3.3, 1.3, and then do venv. So this is the Mac command for it. This also might work on Linux. If you're on Windows, it's going to be slightly different, which is going to be basically the absolute path to where your Python executable is. So it's going to be something like that, then -m venv. Okay. So this is another place where if you don't know this one super well, then definitely check out the course that I have on it, which was this one right here. So just go ahead and do that. Okay, so the idea is now that we've got this virtual environment, all we need to do is activate it. Now, the nice thing about modern text editors or modern code editors is usually when you open them up, they might actually activate the virtual environment for you. In my case, it's not activated. So the way you do it is just by doing source venv and then bin/activate. This is going to be true on Linux as well. Windows is going to be slightly different unless you're using WSL or you're using PowerShell. Those things might have a little different, but more than likely Windows is going to be something like this, where it's venv scripts/activate like that, where you put a period at the beginning. That will help activate that virtual environment. And so now what we do is we can actually do Python-V. Notice the 3 is not on there, and here it is. And of course, if I do which Python, it will now show me where it's located, which of course is my virtual environment. And so this is the time where we can do something like Python-M pip, or just simply pip. Both of those are the Python package installer, and we can do pip install pip --upgrade. This is going to happen just on my local virtual environment. It does not affect pip on my local machine, which we can check by doing pip again. If I do that, notice that it's not working, right? So it works in here where I do pip, but it does not work in my terminal window, non-activated terminal window. If I do Python 3-m-pip, then I'll get it, or rather just pip. that will give me that actual thing, and it's showing me where it's being used just like that. Same thing, if I came back into my virtual environment, scrolled up a little bit, it will show me something very similar. Here's that usage. If I do the Python version, it will show me the same sort of thing that we just saw, but it's going to be based off of the virtual environment, just like that. So that's the absolute path to it. Of course, it's going to be a little bit different on your machine unless you have the same username as I do and you stored it in the same location. But overall, we are now in a place to use this virtual environment. So let's see how we can install some packages and kind of the best approach to do that. Now let's install some Python packages. It's really simple. It's a matter of pip install and then the package name. That is how the Python package index works. If you're familiar with something like npm, these are very similar tools. But the idea here is if you go to pypy.org, you can search all of the different published Python packages, and pip install can install them directly from there. So if we did a quick search for FastAPI, for example, we can see here is the current version of FastAPI that's available, and this is how we can install it. Now, the key thing about these installations is, just like many things, there's many different ways on how you can do this. There are other tools out there, like Poetry is another tool that can do something like Poetry add. I believe that's the command for it. But the idea here is there's a lot of different ways on how you might use these different package names. I stick with the built-in modules because they are the most reliable for the vast majority of us. Now, once you get a little bit more advanced, you might change how you do virtual environments, and you also might change how you install Python packages. But the actual Python, like official repository for all of these different packages is PyPy, and they still say pip install. So it's still very much a big part of what we do. Okay, so the idea here now is we need to install some packages. So how we're going to do this is we're going to go ahead and, once again, I'm going to open up my project. And in my case, I actually closed it out, mostly so I can show you the correct way to install things. Here's my recent project here with that workspace. All I have is a virtual environment and that code workspace in there. Now, if I were to toggle open the terminal, it may activate the virtual environment, it may not. So the wrong way to do this is to just start trying to do pip install FastAPI. In this case, it says command not found. The reason this is the wrong way is because I don't have the virtual environment activated. So I have to activate that virtual environment just like that if I need to manually do it. If for some reason the terminal is not automatically doing it. Then we can do the installation. So we can go ahead and do pip install FastAPI and hit enter and just go off of that. And that's actually well and good, except for the fact that I don't have any reference inside of my project to the FastAPI package itself. So I have no way to, if I were to accidentally delete the virtual environment, I have no way to recoup what I did. So what we need to do then is we create something called requirements.txt. Once again, this is another file that could be done in different ways, and there are other official ways to do it as well. But one of the things that's nice about this is inside of this file, we can write something like FastAPI, and then I can do pip install-r requirements.txt, which will then take the reference from this file, assuming that everything's installed and saved. And so once I save it, I can see that that's the case. It's now doing it. This comes in with the versions then. So what we do then is we can actually grab the version and say it's equal to that version right there, in which case I can run the installations. Now, this is actually really nice because it kind of locks that version in place. Now, if you go into the release history, you could probably go back in time and grab a different version, like 0113.0. If we do that, so 0113 and then 0.0, I save that. Now I run that installation. It's going to take that old one and it's going to install the things that are relative to that inside of my entire environment. Now, in my case, I actually want to use this version right here. And a lot of times I would actually do another tool to make sure that this version is correct. That other tool is called pip tools, which I'm not going to cover right now. But the idea here is we want to keep track of our requirements, and FastAPI, of course, is one of them. Now, within FastAPI, we have something else called UVicorn that we will want to use as well. This is often hand in hand with using FastAPI. So once again, we see pip install UVicorn, and you can just do something like that. Now, there is something else with UVicorn that we might want to use, and that's called GUnicorn. So G unicorn. And we do a quick search for that. This is for when we want to go into production. G-Unicorn and U-Viacorn can work together. So once again, I'll go ahead and bring that in. U-Viacorn and G-Unicorn, they are great tools for running the application in production, but we usually don't have to lock down their version. I think once you go into production, you need regular things, then yeah, you'll probably want to lock down the version. The more important one is probably FastAPI, but even that, we might not need to lock down our version at this stage. Like if you're getting something from what I'm telling you right now, then you probably don't need to lock down the version yet. If you already know, oh, I need to lock down the version, then you'll probably just do it anyway. That's kind of the point. That's why I'm telling you that. But the idea here is, of course, we've got all these different packages. And then, of course, my package that is definitely a lot newer. You do a quick search for it and it's TimescaleDB. It is not a very, there's not that many versions of this package. So this is another one that I'm going to go ahead and not lock down because I definitely don't want that. So within that package, there is something called SQLModel, which is a dependency of the other package. So it's this one right here. This one also doesn't have that many versions itself, but it's pretty stable as it is. And this one works well with FastAPI. And you'll notice that it's powered by Pydantic and SQLAlchemy, which means that we probably want to have those in there as well, just so we have some reference to it. So I'm going to go ahead and bring that in here with Pydantic and SQLAlchemy. There we go. So now that we've got all of the different versions here, I can once again do pip install-r requirements.txt, and then I'll be able to install all of the packages as need be. Now, here's the kicker. This is why I'm showing you, is because what you want to think of your virtual environment as just for the local environment. You are not going to be using it in the production environment. You'll be doing a completely different one. What's interesting is my terminal now opens up that virtual environment and attempts to activate it, which is pretty funny. But I don't actually have one yet. So I'm going to go ahead and re-bring it back. Now I've got that virtual environment back. Of course, if you're on Windows, you might have to use something different here. But I'm going to go ahead and reactivate it with bin activate. And then we'll go ahead and do pip install-r requirements.txt, hit enter. And now I'm getting all of those requirements back for this entire project. This is going to come up again. We will see it for sure because it's really important. Okay, so now we've got our requirements. We've got our virtual environment. It's time to actually do our FastAPI Hello World. Before we go much further, I will say if there are file changes within the code, it will be on the official GitHub repo for this entire series as to what we're doing going forward. So in other words, in branches of start, this is the branch we're going to finish off with. Of course, this one doesn't have everything in it like we just did, but it will. And so that's the start branch. That's where we're leaving off. But as you see, there's license and README. Those things I'm not going to show you how to do, or the get-ignore file. They're just going to show up in just a moment. But now that we've got this, let's go ahead and actually create our first FastAPI application. It is very straightforward. We now want to do our FastAPI Hello World. So the way we're going to do this is by creating a Python module with some FastAPI code and just run it. The key part of this is just to really verify that our package runs, that it can actually go. So to do this, we're going to go ahead and go back into our project here. And of course, I want to open up my terminal window. If the virtual environment activates, that's great. If it does not activate like that, then we want to activate it manually. Every once in a while, when you create a virtual environment, you might see this where it automatically activates. We hope that it will start to automatically activate. I'll mention as to when it might happen. But the idea here is we want to activate that virtual environment. So source venv bin/activate, or of course, whatever you have on your machine. Then I'm going to go ahead and do pip install-r requirements.txt. It's not going to hurt to run that over and over and over again, right? It never will, because if it's already installed, it's not going to do anything. Cool, other than tell you that it's already installed. So the idea here is we want to make sure that it's installed so we can actually run it. The next question, of course, how do we run it? Well, if we go into the FastAPI documentation and we go to the example, we see here's some example Python code. So it says create a file main.py with all this stuff. So the question then is, where do we actually put this? And that's going to be as simple as you could do it right here in main.py. You can copy this code, paste in here, save it with Command S, which is exactly what I do a lot. I won't actually show you that I'm saving it. I'll just save it. I just saved it like 10 times just there. So now that we've got that, we actually want to run this code, right? So how do we actually run it? Well, going back into the docs again, you scroll down a little bit, you see that it says run it right here. And so I'm going to go ahead and attempt to run it with FastAPI dev main.py, hit enter, I get an error. So there's a couple things that I want to fix before this goes any further. But the idea here is this might make you think that, oh, we didn't install FastAPI correctly. And in a way, we didn't. We didn't install it to use this particular command line tool. It is a piecemeal command line tool. It's not necessarily going to be there by default. In this case, it's simply not there. Now, in my case, I could consider using this as my development server for FastAPI. What I actually want to use is UVicorn because it's closer to what I would use in production, and it's actually what FastAPI is using anyway. You look in the documentation, you can scroll down a little bit. It says, we'll watch for changes, UVicorn running, and all that. So it's basically UVicorn anyway. So that's what we want to do, is we want to have UVicorn run our actual main app. So you use UVicorn then, this is the command. If you hit enter, you should be able to see this. Now, if you're on Windows, you might actually have to use Waitress at this point. Waitress is just like UVicorn, but that might be the one that you end up using. We'll talk about solving that problem in just a little bit when we go into Docker, but for now, I'm going to be using UVicorn. And of course, if you are on Windows, go ahead and try that FastAPI standard. That will probably work for you as well. Okay, so the idea here is now we want to actually run this application with UVicorn. And then the way we do that is we grab main.py here, and then we use : looking back into main.py, we look for the app declaration for FastAPI, which is just simply app. And then we can do something like -- reload, hit enter. Oh, that trailing slash should not be there, so I'll try that again. We hit enter, and now once again it says we'll watch for these changes, and it's running on this particular port, just like what we see right in here. Great. It just doesn't show us this serving at and docs at and stuff like that, as well as there's not a production version of this just yet that we'll use. We will see it though. Okay, great. So now I can open this up with command click or just copy this URL. You can always just control click and then open it up like that. But the idea is, hello world, it's running. Congratulations. Maybe this is the first time you've ever run a FastAPI application, and it is up and running and it's working on your local machine. Now, don't get too excited because you can't exactly send this to anybody, right? So if I were to close out this server, which we have a few options to do so, one is just doing Control-C, which will do that. It just literally shuts it down. Another option is just to, kill the terminal. And then you can open up the terminal again, in which case ours right now, we need to then reactivate it, and then we can run that command again. By just pressing up a few times, we'll be able to find it, and there it is. Okay, great. So now we have it running. What can we do? We need to actually put it in a location that makes more sense than where it is. Right now, main.py is in the root folder here. This is basically something that no one ever does. When you start building, professionally, you often put it inside of src main.py like that. Notice that I put that slash in there. That's important because as soon as I hit enter, it actually creates a folder for me with that new module, which is where I'm going to go ahead and actually paste all of that code again. And then I'll just go ahead and delete this one with command backspace. That allows me to delete it. Of course, there's other ways to delete it, but there we go. Okay, so now we can verify that FastAPI is running. It's working, it's ready to go. So if you're on Windows and you have Docker installed, or if you just have Docker installed, the next part is going to allow for us to build on top of this, or the next half of this section is going to help us build on top of this so that we can actually use this code a little bit more reliably than we currently do. Let's say you want to share this application with one of your friends and you want to help them set it up to run it. What you'd probably tell them is, hey, download Python from python.org, make sure that you create a virtual environment, install these requirements, and then use UVicorn to run main.py. And then you remember, oh wait, you also have to activate the virtual environment, then install the requirements, then run with UVicorn. Then you might remember, oh, make sure you download Python 3.13 because that's the version we're going to be using. So there is some nuance in just the setup process to make sure that this is working correctly that, of course, you and your friend could figure out by talking, but it would be better if you could just give them something and it just worked. Docker containers are that something. What we end up doing is we package up this application into something called a container image, and we do it in a way very similar to what we've been doing, which is download and install the runtime that you want to use, like Python 3, create a virtual environment, activate that virtual environment, install the requirements, and then run your application, your FastAPI application. So we will get to the point where we actually build out these things very soon. But right now, I want to just show you how you can run them, how you can just use them by downloading Docker Desktop. So if you go to docker.com and hit download Docker Desktop for your platform, you'll be able to get the Docker Desktop user interface just like this, but you will also, more importantly, get Docker Engine to be actually able to run Docker containers, to be able to create them, and to be able to share them, the key parts of using Docker. Now, Docker itself can be really complex, so I want to keep things as straightforward as possible. So it's very similar to what we did with Python when we downloaded and installed it, but we're going to do that the Docker way right now. So at the point that you download it, you're going to go ahead and open it up on your machine, and it's going to look something like this UI right here. Now, if for some reason this isn't popping up and it's just in your menu bar, you might actually see that. As soon as you exit out, it might be something like this, in which case you'll just go to the dashboard and that will actually open it back up. That's just off of the recording screen for me right now, which is why you're seeing it this way. But the idea here is we now have the Docker Desktop on our local machine. Now, I also want to verify that this is working correctly, because if I don't verify it, then it's going to be hard to run in general. So opening up the terminal, I should be able to do Docker PS. Docker PS really just shows me all of the things that are running on my machine. We'll come back to this in just a moment, but the idea is if this runs an error, you don't have it done correctly. The error will look something like that. So just type in gibberish, that's the error, right? Command not found in this case. So I want to make sure that that's there, and I also want to make sure that Docker Compose is there. We'll come back to Docker Compose really soon, but for now we're just going to have those two commands. Now I'm going to be giving you a very minimal version of using Docker and learning how to use Docker over the next few videos or next few parts of this section. Now the reason for that has to do with the fact that we need it for a very stable local development environment, but also so we can push this into production. So let's actually take a look at how we can actually use a Docker container image right now. So on Docker Desktop, there's this Docker Hub right here. There's also Docker Hub if you go to hub.docker.com. Both of these things are just simply Docker Hub, and you can search for other container images. It's not surprising that if you look at the Docker Hub on Docker Desktop versus the website, they look basically the same. That's, of course, makes a whole lot of sense. Now, in our case, we're going to go ahead and do a quick search for Python. We want to do the Python runtime. So when we went to python.org, we went to downloads, and you could have gone to one of your platforms here, and you could actually grab a specific version of Python. So this is true on Docker Hub as well, but instead of saying download, it's just a tag. So you just go into tags here, and you can find different versions of Python itself. You can get the latest version, which often is a good idea, but just like what we talked about with the actual versions of packages or Python software that we're using, a lot of times you want to use a very specific version to make sure that all of these things work as well. So going back into the Docker Hub, we'll do a quick search for Python 3.13. And so what we see in here is Python 3.13, the one we've been using. Here's 3.13.2. And of course, if we go back into actual Python releases, we can see there's 3.12 right there, and it's the same one. Exact same one. One is through Docker, one is directly on your local machine. So the one through Docker is going to work on Linux, Windows, Mac. It's going to work cross-platform. It's really great that it does that. But I actually don't want to use the version that I already have on my machine. I want to use a really old version. So Python 3.16. And we've got 3.16.15. That is super old. And we can see just on Docker Hub that this is about 3 years old. And it's only going to get older. It's going to be less and less relevant, and it has vulnerabilities. There's a lot of security concerns with using this old one for our production systems. But for this example, there's no concerns at all. We can delete it. It's really simple to do. So the way we actually get this thing working is by copying one of these pull commands. So we can scroll on down. I'm going to go ahead and just grab the one that is 3.6.15. I'm going to go ahead and copy this command here, go into my terminal, and I'll go ahead and paste that in with that pull command. So this is going to go ahead and download Python 3.6.15 directly from Docker Hub. It downloads it in the image or the container form. So we can now run this with Docker run Python 3.6.15 and hit enter, and it immediately stops. So the reason it immediately stops is because Docker itself has a lot of features. It can do a lot of things. One of those things is we can do an interactive terminal for this, which is -it with that same Docker container image, and we can hit enter there. Now it actually opens up Python for me. It's quite literally in the Python shell, much like if we were to open up a new terminal window here and type out Python 3 in there, that is also a Python shell, right? The difference here is if we actually clear this out, I can just run it at any time and I can change the version. There's also another difference. It says Linux up here and Darwin down here. That's because on my local machine, I'm on a Mac. But in the Docker container, I'm on a Linux. So Docker containers are basically Linux with a bunch of things already set up. Now, the other cool thing about this is I can exit out of here, of course, and then I can run Python 3.7. And now it says it can't find it, so it's going to go ahead and download it for me. All the while on my local machine, if I try to do Python 3.7, it's not available. Python 3.6, not available. Very similar to using a virtual environment, but it's another layer of isolation. And it allows us to have these packaged runtimes that we can use at any time, which is fantastic. So the other part about this, of course, is that inside of Docker Desktop, we can delete these old ones that we don't want to use. And you're going to want to get in this habit sometimes to make sure that you don't have these old versions of Python on your machine because they're rather large. That's why there's other versions or other tags of it, right? So if you go back into Docker Hub, you'll see that there's this slim buster. Look how much smaller of an actual Python project it is. It's way smaller. So you could just grab that version and then you can come in here and do the same thing. Docker run -it, that version right there. This is going to download it. It's going to be much smaller, which means that it probably doesn't have nearly as many features out of the gates. It's still on Linux, but we can do, all sorts of Python things in here as you would. And then you can then see inside of Docker Desktop all of the things that are downloaded in here. And then the Slim Buster is quite a bit smaller than these other ones. And so another thing about Docker Desktop that's really nice is you can come in here, you can search for Python, and you can do a quick search, which gives us all of these ones that are using the Python image. All of these are running versions of the application, which you can stop and delete, which you would want to do. And then you go into your images. You can also delete these as well, just like that, which gives you back 2 gigs of space, which you're definitely going to want to get in the habit of doing. In which case, then when you want to run it again in the future, it will just go ahead and re-download that image, right? So it's really meant to be ephemeral like this. You're meant to think of Docker as something that is temporary. So you can add it, remove it, run it when you need to, and then delete it when you don't, right? And so every once in a while you'll see, hey, you can't delete it because it's running. So then that means you just go into the containers here. These are ones that are running. You just go ahead and delete that. You go back into the images and then you can delete it. Worst case scenario, you just literally shut down Docker Desktop, open it back up, and you can see what's running with Docker containers in here. Or you can use Docker PS to see if anything's running. Right now I don't have anything running, which is very clear in the desktop as well as my terminal. Okay, so we'll continue to use this. I don't expect you to know all of Docker at this point. You shouldn't know all of Docker at this point. Instead, you should just be able to benefit from using Docker, which will allow for us to do all sorts of rapid iteration and isolate our projects from each other on a whole nother level, well beyond what virtual environments can do. And it will allow us to have as many database instances as we might want, which is what we actually want to do very soon by using Timescale itself. So that is the Docker Desktop and some things about Docker Compose. Now I actually want to get FastAPI ready. We want to actually build our own container for FastAPI, or at least the makings of it. Then we'll go ahead and take a look at how we can develop with Docker itself. We are now going to bundle our FastAPI application as a container. The way we do this is by writing some instructions in a specific syntax so that Docker can build the container from those instructions and our code. So this is called a Dockerfile. So we've got a production Dockerfile for FastAPI. The reason we're doing it now is because the sooner we can have our project optimized for production, the sooner we can actually go into production and share this with the world or anyone who has a Docker runtime. Those things are the key part of this. So the actual Dockerfile we're going to be using is on my blog. So it's here. This is a production version that you can just go ahead, grab, and run. I'm going to make a modification to it for this project, but that's the general idea here. So I'm going to open up my project now. I'm actually going to copy these steps. You don't have to copy them, but I just want to lay them out so I know where I want to go with this instruction, this Dockerfile. So if I go into Dockerfile like this, no extension, I'm just going to go ahead and paste this out. And these are the instructions I wanted to do. First off is download Python 3, create a virtual environment, install my packages, and then run the FastAPI application. Those 4 steps are really what I want to have happen. Now, the way this works is very similar to like when we ran our Python application itself, right? When we ran it just with Docker itself, we can see that it is in Linux, and here is our Docker application. So it really starts at this tag here, the container and its tag. So the way we find this, of course, is by going into Docker Hub, looking for a container image like we did, looking for the version that we want to use, and then also the tag that we want to use, which of course is going to be 3.13.2, which we had locally. That's the one we downloaded in the first place. We're going to use that same one for our Docker container. So the big difference here, though, is we don't want to use the big one because it's massive. It's massive all across the board. We want to use a small one, which is called Slim Bullseye. So that's the one we actually want to use. And so the idea here is very similar to what we have with the Slim Buster from the original Python download in the Docker container. We're going to do something very similar to this. The way it works is we say from, this is the Docker syntax for it, the actual image that we want to use, which we could use latest. This might be 3.13. This might be 3.14. This might be 3.15. We want to be very specific about the version we're going to use, which again, 3.13, and then I think it was .2 is the baseline one. If you do Slim Bullseye like that, it will be a much smaller image. As soon as you do a much smaller image, we lose some of the default things that might come within Linux itself. When we lose that, that means we need to also install our Linux environment. So the next step might be, set up Linux OS packages, right? So if you were going to deploy this directly on a Linux virtual machine, you would need to do that same idea, that same concept here. Now, I could go through all of these steps with you, or we could just jump into the blog post and copy it, because this is not a course about Docker. So I'm going to go ahead and copy what's in this blog post, and we'll go ahead and bring it right underneath those comments. And I'm going to go ahead and modify this a little bit to make it work for our project. The first thing is, notice that I've got this argument in here. We actually don't need that argument. We're just going to go ahead and stick with that single one right there. And then I'll just go line by line and kind of explain what's going on. First off, we create that virtual environment. No big deal. This time it's going to be in a specific location. This is like as if we were setting up a remote server. We would want our virtual environment in one location because that one server is probably going to have only one virtual environment for this particular application, which is what we're doing with our container. This one container is going to only have one Python project, but we still want to use the virtual environments to isolate any Python that might be on the operating system itself. So now that we've got this virtual environment here, this little command right here makes it easy so that we don't have to activate it each time. It's just activated. And so we can run the pip install command and upgrade pip. We do Python related stuff. Here's the OS dependencies for our mini virtual machine or our mini server here. We can then install things like for Postgres, or if you're using something like NumPy, you would have other installations in here as well. Or if you wanted to have Git in here, you could install that as well. So a lot of different things that you can do on the OS level. And that's it right there. So that's one of the cool things about using Docker containers themselves is you also control the operating system, not just the code. So what we see now is we are making a directory in this operating system, this mini one called code. We have a working directory in here also called code. In other words, we are just going to be working inside of there. Then we copy our requirements file. Hey, what do you know? Requirements.txt into an absolute location. This doesn't matter. We could actually not have it in an absolute location, but it is nice that it is in one because later when we need to install it, that's what we do. And so what we see here is it copies the code into the container's working directory. In other words, it's copying main.py into a folder called code. No big deal. Now we've got a few other things that we probably don't need in here. And then the final one is actually running a runtime script, a bash script to actually run this application, and then removing some of the old files to reduce image size, and then finally running the actual script itself. So what I want to do before I say this is done is I actually want to create something called boot/dockerrun.sh. Now the reason I'm doing this is because all of us are going to need to know what it is that's going on with our application at any given time, and this is what it's going to be. So we first off make this a sh file or bin/bash file so that the Linux virtual machine will be able to run it, the Linux container will be able to run it. Then we want to cd into the code folder. We also want to activate the virtual environment. Then we have runtime and variables to actually run our application, which is going to be an src main app. And that is a little bit different than what we've got here, so I'm going to go ahead and just keep it in as main app just for now. We might change this in the future, but this is going to be our script to actually run our application. And so to use that script, what we do then is we are going to go ahead and copy the ./boot/dockerrun.sh, and we're going to go ahead and copy that into opt run/sh. So instead of this script here, we've got a new one, and that's going to be the name of it. Then we want to do the chomod to make it executable. Then that's what we're going to end up running is that script right there, and make sure it has a .sh, and that's it. So of course I still need to test and make sure that this is working. It's not necessarily working already. So I will have to make some changes in here just to make sure that that's the case. That's not something we're going to worry about yet. The main thing here is that we have a Dockerfile and that we're going to be able to build it really, really soon. This Dockerfile most likely won't change that much. If anything, the blog post will give the updates to the change, or the actual code itself will have this Dockerfile in here. That's the key of Docker files. They don't need to change that much. The only thing that will change most likely would be the Python version that you end up using over time, and then the code that's going in. But everything else related to this is probably going to remain pretty static. That's also why in the blog post, the way we run the actual application itself is written right in line. It's actually a script that's created right in line. But having it external makes it go a little bit faster than what we have right here. Now I realize some of you aren't fully ready to learn the ins and outs of Docker, but we want to be as close to production as possible, which is why that blog post exists, and it's why you can also just copy this stuff. Personally, I think looking at this, it's hopefully very clear as to the steps that need to happen to recreate our environment many, many, many times over, so that it's a lot easier to share it, whether it's with somebody else who has a Docker runtime or with a production system. Over the next few parts, we're going to be implementing the Docker Compose based FastAPI Hello World. But before we get there, we need to still see some things about Docker just so you have some foundation as to what's happening in Docker Compose. So jumping back into our project here, we've got this Dockerfile. These are the instructions to set up the tiny little virtual machine or the tiny little server to run our application, right? It bundles everything up on our code. So we need to actually be able to build out our application. So there's really two commands for this. I'm going to put them in our README here. So we'll go ahead and do Docker in here, and we'll go ahead and do the two commands. And it's Docker build, and then it's going to be Docker run. Okay, so build is what it sounds like. It's going to build our bundled container image. And the way we do it is we tag it something. Hey, these tags, what does that remind you of? Hopefully it reminds you of a few things. A tag like this, and in our terminal, a tag like this, right? So we need to tag it in the same way. It's going to be tagged on our account if we were pushing it into Docker Hub, which we're not, but we still need to tag it. So either way, we're going to build it and tag it. Then we want to say, hey, where are we building this file? Well, we're going to build it in the local folder, which is just period there. Now, we also want to specify the Docker file we're going to use, which is how we do it like that. Now, if you don't specify the Docker file, it's just going to go based off of that, as in no other Docker file. The reason being is you can have multiple Docker files like dockerfile.web, in which case you would want to specify something like dockerfile.web. We aren't doing that. We're just using the one single Docker file, but it's important to know about if you were going in that direction on how you go about building it. Once you build it, then you run it. Hey, what do you know? Build it, then run. Now we've already seen that command a little bit as well too, which was docker run and then that Python command like this. Now, the thing about this run command is there are a bunch of arguments that can go in here. There can be the -it argument like we saw with Python. We aren't going to spend any time with the arguments in here. In fact, this is all we want to see for our arguments at this point because we actually want to use Docker Compose because it will do all of this for us as we'll come to see. So the idea here is we want to build out the container. Let's go ahead and do that in the root of our project right next to the Docker file itself. I'm going to go ahead and run this command and it's going to go ahead and build this out for me. Now in my case, it actually went really fast because there's this cache in here. I actually did test this and built it already. So if I go into Docker Desktop, I can see the image that was built in here, which will be my image, my actual Docker Analytics app image in here. So I have got a few of them in here, and the reason that I have a few is because I was testing this out. But of course, you can delete these just like we've seen before. In this case, we've got one that I can't actually delete yet. So I'll go back into my containers in here, and let's go ahead and get rid of the search bar. And I'm going to go ahead and stop all of my containers and delete all of them. And then I'll go back into my image here and I'm going to delete this one as well, just so I can see it being built out. I also wanted to show you that's what you do if you want to get rid of it, whether it's your app or someone else's. And so once again, it still has cache in here, so it's going really, really fast, which is super nice. But sometimes it will take a little bit longer than that. Now there's this other legacy warning that we've got in here because one of the Docker files needs to be changed a little bit to having equals instead of that space bar there. So I'm going to go ahead and do that, and I'm going to try and build it again. Cool. So it builds really fast. Great. So now I've got a container image that I can run. It's not one that's public. It's only on my local machine. It goes public when I push it into Docker Hub, which, like I said, we're not going to do at this point. So to run it, I just go ahead and do Docker run, and then whatever that tag is, in our case, that tag is Analytics API, which we can also verify inside of our images in here. There's the tag itself. Well, actually, it's the name of the container with latest in here. So it actually defaults to latest. That's the tag. That's how you actually can do it. It's going to default to that if you don't specify. So if you were to specify one, it would just be like that. Again, we'll do some of this stuff with Docker Compose in just a little bit. So now all I really want to do is verify that I can run this application by doing Docker run, and there it is. It's now running the application itself. If I try to open this application, it's not going to work. We will make it work in a little bit. The reason it's not working is because of how Docker works itself. Everything needs to be explicit to make it work. So in order for it to run on a specific port, we also have to let Docker know about that. The application itself doesn't have to let Docker know about that. We've got a lot of control over how all of that works. So what I want to see now is how to do these two things inside of Docker Compose. Off the video, I went ahead and stopped that container and deleted the built image so that I could then run the command docker run analytics API, which of course failed. It's not locally and it's also not on Docker Hub, so it just can't run it. So that's a little bit of an issue that actually is overcome by Docker Compose. So if we go in here and do compose.yaml, we can actually start specifying the various services we might need. So the very first key in this YAML is going to be services. Inside of there are going to be all of the container images we might want to use, like a database or our app. In this case, we'll go ahead and just work off of our app. The nice thing about modern tooling is a lot of times you can just run individual services right inside of the YAML file. It also might depend on an extension that I have installed. But the point here is we want to make sure that we have these nested key value pairs here. App is just what I'm calling it. I could call it SRC, I could call it web app, I could call it a whole lot of things. What we call it is going to make more sense, or it's going to matter more later when we use something a little bit different than just app. Okay, the idea here then is we've got our app, and now we want to specify the image name. So what do we want to call it? Well, we could call it the same image name as in Analytics API, and this time we can say something like V1. Okay, great. Next up, what we can do is define the build parameters here. and that is going to be our context, which is going to be the local folder. This should remind you of this dot right here. So that's the context that we're looking at. And then the next part is specifying the Docker file we're going to use relative to the compose file. So we'll set Dockerfile, and it's going to be Dockerfile, just like that. Now, if we had this as Dockerfile.web, which you might do at some point, then you would just change this to .web as well. Let's actually keep it like that so it's a little bit more clear as to what's going on in here. Now, if we do change it, one note I will change is inside of my little command here, I would want to change that one as well, just in case I wanted to build it individually. Okay, so the idea now is I've got my Docker image and some build parameters. Now you can actually add additional build parameters in here. This is all we're going to leave though, is the context and the Docker file. In part because it actually matches what we did to build it in the first place. But the other part is, well, we probably don't need a whole lot of context just to build it because that's what the Docker file is for. The Docker file has a lot of those context things that you might need to build it. Now to run it, it's a whole nother story. So to run it, what we did was, well, actually, if I just leave it like this and try to run it, we'll see something interesting. So I'm going to go ahead and clear this out and then do Docker compose up, hit enter. What this will do is it starts to run it, but it actually ends up building the application itself, and then it goes to run it, which it is now running. And of course, if I were to go to this actual place, it will still not work, right? Okay, so we'll get to that in a second. But it built and ran it basically the same way, but now we specify the image here, and so the command I need to remember is just simply Docker compose up. And if I want to take it down, I can open up another terminal window and do Docker compose down. That will stop that container application from running, which I think is pretty nice. Okay, and then we can also go into Docker Desktop. We can take a look at the images in here and look for our Analytics API. And what do you know? There's that V1 tag in there as well, which makes things a little bit nicer and easier to see what's going on. So the image was built with that tag is kind of the point. Okay, great. So now what we want to do though is we want to be able to actually access this endpoint, this URL here. So the way it works with Docker, this is true whether it's Docker Compose or just straight Docker itself, as in this run command, we actually need to specify ports. So part of the reason that I actually had ports in the first place, like inside of my Docker run, is so that I can specify a different port, right? So this port value, this environment variable, we want to play around with this in just a moment. So the way we play around with this is going to happen next to ports. So before I actually do the ports, let's go ahead and change the environment variable. So we're going to go ahead and come in here and not to use entry point, but yeah, rather use environment and set key value pairs. So the port value you want to use. So let's go ahead and use port value 8002. I'm not going to do the ports just yet. We'll just change the port and then I'll go ahead and do Docker compose up. Notice that the environment variables have changed. If I try to open it once again, it still is not accessible. Okay, so this is in part because what I changed was runtime arguments. This little thing changed a pretty big change inside of the application because of this environment variable, or more specifically, this one right here. So inside of our compose.yaml, we've got this port value in here. Now, the reason I'm mentioning this is because at some point we will have a database URL in here, and we'll be able to pass in what that argument is. Another thing that we can do inside of using, just Docker Compose is do an env file, and you could do something more like .env, in which case you could just come in here and do .env, and this being port like 8001. So right now I have conflicting environment variable values, so let's actually see what that looks like. I'm going to go ahead and call Docker Compose down, and then we'll go ahead and bring it back up in just a second. Okay, it took a few seconds for that to finish, but now if I do Docker Compose up, it's still port 8002. In other words, these hard-coded environment variables override the environment variable file. So if I were to get rid of that port, it would still be, whatever the environment variable value is. So for now, I'll just leave them the same so there's not any confusion. But the idea here is we have the ability to have environment variable files. Now we can add more of them by just using another line here. You could do something like env.sample or any other kind of environment variable files. And of course, it has to be in this format of key equals some value. Okay, great. So the final step here is really just to expose this port. So I'm going to go ahead and bring this down. And the way this works is we declare ports in here, and this is super cool. So what it shows us is our host port and our container port. So if I click on that, we've got host port of 8080 goes to container port of 80. If you're not familiar with what the container port is, that is going to be this number, right? So port 8002. And then the host port is our system. What port do we want to access port 8002 on this? So this sometimes doesn't work as intended. So we're going to go ahead and try it out. We've got Docker Compose up. Here's 8002. And then we exposed port 8000. So inside of my local host here, I'm going to try to do port 8080 and see if I can connect. So depending on how your system ends up being designed, this might work and it also might not work. So what you want to typically do is default to your local host port to that port itself. The reason for this has everything to do with how our port and host and all this sort of stuff is being mapped. It sometimes works very seamlessly, sometimes does not. Basically, the general rule of thumb is if you have the ability to use the same port, you should. But the reason I wanted to show you all these different ports here is because this is kind of confusing. It doesn't really show you what's going on. You just need to remember the first port is going to be our systems port. The second port is going to be the port that the Docker container app is running on. Great. So now we can go ahead and bring that back down, and then we'll go ahead and bring it up in just a second. Okay, let's bring it back up, and here we go. So we got port 8002. We open this up, and now we've got the hello world in there. So congratulations, you have Docker Compose working. Now, this stuff I realize might be a little complicated if you've never done this before, but really these are just a bunch of arguments that we are telling Docker to use for this particular container image that's being built locally. You don't always build things locally, as we saw before when we actually had a Python project, but when we do build things locally, we have a whole nother set of stuff that we can do. So for example, we can change the Dockerfile command here, the one that starts the application, the runtime script. We can change it to something different, something like uviacorn main app, and then the host, port, and reload. The nice thing about this then is it's actually going to be built off of that command. It's not going to be using the gunicorn script at all. So if you made any mistakes with that, you could just use this command to run it. And of course, you would take it down and make it all work just like that as need be. So the next thing about the Docker Compose stuff is you can do something like this, where you can actually watch for changes on files and it will rebuild the entire container. We'll see that in just a moment. Now, if you wanted to rebuild the container, or if you want to be able to do your own development, you're going to do one more thing, which is attaching a volume to this container. So this volume here is going to go ahead and grab this folder of source, and it's going to go ahead and put it where we want it to. Right now this says /app, which may or may not be the correct location we want to mount source. So this means that we go back into the Docker Compose file and we scroll down and we see where we copy our SRC folder, which actually goes into /code. So we just make a minor modification to this volume here, and that means that we are going to go ahead and basically copy our code into the container constantly, and then we'll be able to rebuild it. So this might be confusing, so let's go ahead and see what I mean by all of this. We do Docker Compose up --watch. So what's happening here is we see that watch is enabled. If I were to change something to requirements.txt, let's go ahead and say bring in requests here, like Python requests, and I just go ahead and save it. This rebuilds the container image. It's going to happen right away. Now, this might take a few moments because that's exactly what does happen when it comes to building out containers. But there it is. It rebuilt it and then it restarted the application altogether. So the next thing is actually changing the code. But before we do that, let's take a look. And here we see hello world at port 8002. Now inside of main.py, if I change this to hello world or something like that, we should be able to refresh in here and it automatically changes, which is super nice. So really the command we want to use from now on is --watch in here so that we can actually just change our code. We now have a Docker-based development environment. All you'll need to run now going forward is Docker Compose up and watch. And then if you do need to get into a command line of this Docker image, you can do so with simply docker compose run, and then the service name, which is in the compose.yaml. In our case, it's simply app. So if we come back into our README here, we can just go ahead and say app, and then you can put in something like /bin/bash, which will allow you to go directly into the command line shell. Now you could also see something like, or you could do something just like that, but instead of bin/bash, you could just go ahead and say something like Python, right? That should actually work as well, which will give you the virtual environment version of Python. So let's go ahead and try either one of these out so you can take a look at what we're doing here, and then we'll be able to see that I have this runtime ability in here as well. So every once in a while, you'll see this removed orphans. You might want to just add that in to a command as well whenever you run it. But we're going to leave it like this. Here is that version. If I import OS and then I print out os.get current working directory, I think that's the command. We hit enter and we see that we're in code. If I go to exit it exits the container altogether. So what I typically do is not run Python directly, but I want to go into the command line, kind of like SSHing into this container to then run off of that. And then in here, I will be able to list things out. And there's main.py, which is quite literally this code right here. And so we can actually see that as well by doing cat main.py. This will show that code in there. If I were to change main.py in here to something different, to like hello world, and then let's clear this out again, and then run cat main.py, it changes and shows that actual code right there as well. So now we have a mostly complete development environment that we can use through Docker. There are other things that we might want to expand on this, but if you've ever thought about, hey, I want to use a even more isolated environment inside of my project, this would be the way to go. But the main thing about this is mostly to be prepared for production, which I think we are well prepared for production. Now, in the next section, what we want to do is actually start using another service in Docker Compose to actually start building out the data schema that we want to use. The key takeaway from this section is that we now have a production-ready development environment. Of course, this is thanks to Docker containers and this Dockerfile right here. Now, the compose file helps us with the development environment. The Dockerfile will help us with the production environment, but both of them together give us that production-ready development environment. Now, this is more general, right? It's not necessarily about our Python application, which of course means that we also need to make sure that our Python application is ready for a local development environment as well, which is why we started it there. Some of you may or may not use the Docker Compose stuff during development, and that's totally okay. The key thing is that it's there, it's ready, and we can test it when we're ready. In other words, if you need to just run your UVicorn and activate your virtual environment and run that on your local machine like that, that is totally okay and it's more than acceptable. When it comes to the actual Docker Compose though, we can also just have that running if we need to, because the way the actual Docker Compose file is developed is it will react to changes that you make with your code, or at least sync those changes. And a lot of that has to do with all of the different commands we put in here. So like we saw when we changed our requirements.txt, the entire Docker container was rebuilt and then started to run again thanks to Docker Compose watch. So this really gives us this foundation that we can build off of. Now, does this mean that we're not going to change anything related to Docker or Docker Compose? No. As our application develops, we might need to change how it actually runs, whether that's in Docker or Docker Compose, or whether that's locally just through Python and virtual environments. But the key thing here is this foundation can be used on other Python applications if you want, and with slight modification to the Docker file, you can also use it in Node.js applications. Now, Node.js applications will also follow this same sort of pattern. That's the cool thing about the Dockerfile itself, is that it has, well, very step-by-step instructions that are going on here. And of course, you could use this to deploy things manually as well. So if you don't want to use containers when you go into production, this Dockerfile will at least help you with that as well. So we're really in a good place to start building on top of our application and really just flush out all of the features we want to use. Now, we still will use Docker Compose for other things. We still will use the Dockerfile for other things. But the point here is we have the foundation ready, and that was the goal of this section. Let's take a look at how we can start building new features on our application to really make it the true analytics API. In this section, we're going to be building out API routing and data validation. We are creating something called a REST API, which has very static endpoints, that is predetermined URL paths that you can use throughout your entire project. And so FastAPI is really good at building these things, which is the reason we're using it. But the idea here, of course, is you're going to need to have some of the code going, and I'm going to be using my Docker Compose version of this with watch running. So if you don't have Docker Compose up and going, you can use just straight Python, of course. What you'd want to do is clone the repo itself. And if you are going to use straight Python, you'll create a virtual environment in there, and then you'll navigate into SRC, in which case you will do the Docker Compose command, which is this one right here, and you would just maybe change the port, or you could use the same port. So in my case, I have both of these things running, and they are allowed to access. So either one works. The point here is being able to develop on top of what we've already established previously, and so we can actually build out the API service. Now, there's one other thing I'm going to be doing here is I'm going to be using something called Jupyter Notebooks. And I'm going to go ahead and create a folder called MBS here, and it's going to be simply hello-world.ipython notebook, or IPYNB. And so in here, I'm going to go ahead and create some code and print out just simply hello world. And then I'm going to go ahead and run this with Shift Enter. This will then prompt me to select my Python environment, which is going to be my local virtual environment right here. This, of course, means that I'm not using Docker for this. The reason I don't want to use Docker for this has everything to do with how we're going to test this stuff out. And so I'm going to go ahead and install this, it's asking me to install the IPython kernel in here, and we want to do that. Obviously, you can add this to requirements.txt, but Cursor, VS Code, Windsurf are all really good at actually just running Jupyter Notebooks right in line, which is why we're going to use it right here. So this is pretty much it for the intro. Now, using these Jupyter Notebooks, we will then test out all of the API routes we put in and make sure that they're working as intended. Let's jump in. The purpose of REST APIs, or really API services, is so that software can communicate with software. You're probably already well aware of this, but since we're having software automatically communicate with each other, we want to make sure that we implement a health check almost first and foremost, so that if the software has a problem reaching it, it could just go to the health check to see if the API is down or not. So that's where we're going to start, and this is really just a low-hanging fruit way of seeing how we can build all this stuff out. Now, inside of main.py, I'm going to go ahead and copy my read root here, and I'm going to paste it underneath everything, and I'm going to just change the path to simply health with a Z. Health check API endpoints are usually just like that. It's not usually health, but it has a Z in there. Not really sure why, but basically what we want to do here is rename the function to something different, and we'll go ahead and say read API health, something along those lines, and we'll go ahead and say status being simply okay. In other words, we can tell the designers that are going to be using this API, hey, if you need to, just go ahead and run this health check. This is also going to be really important for us when we go into production. So now what we want to do is actually test out this health check. So inside of my NBS here, I'm going to keep this hello world going, and I'm going to import a package called requests. So Python requests is a really nice way to do API calls. This might be what you end up using in the future. There's another one called HTTPX. Both of them are really good and have a very similar way of doing HTTP requests. Now, what I see here is I actually don't have the module called requests or Python requests itself. So Jupyter Notebooks, one of the other nice things about these sort of interactive environment is I can run pip install requests right here. And what it's going to do is it's going to use the environment that you set up at the beginning of this one, right? It's going to use that virtual environment to install the packages you might need, in which case you can just run something like that. Every once in a while, you might need to restart the kernel, which you just hit restart, and there it goes. Once it restarts, you have to run the various things. And at this point, Python request is installed on my local virtual environment. Okay, so I'll leave that out for now. I don't actually need it any longer. So feel free to comment these things out and realize I'm doing shift enter a lot to actually run each cell itself. Okay, so how do we actually call this health check itself? Well, the way I think about it is my endpoint, the endpoint I want to use, which is going to be health Z. And then I'm going to go ahead and do like my API base URL, which I often do something like this, base URL, and it's going to be http://localhost, and then the port we're going to be using. In my case, I'm using port 8002. Now, if you're not aware, localhost is also the same thing as doing 17.0.0.1. Those two are interchangeable in most cases. Okay, so endpoint maybe actually is not what I want to do. I want to say path here, and I'll go ahead and say the endpoint is the combination of these two things, which I'll just use some string substitution to make that happen just like that. So now we've got our endpoint here, and I can print that out, and that's pretty straightforward. Now, if I could do a command click or a control click, I can actually open up the web browser and see this right here. Now, of course, we want to build towards automation. Since we're using our API service, we're going to go ahead and say the response equals to request.get, this endpoint right here. And then all I want to do is print out response.ok. Okay, so I'm going to go ahead and run this. And what it does is it gives me a true value. Great. If I change the path to something like ABC on it, and run those two cells again, I get false. Fantastic. Okay, so I'm going to keep it in as just simply health, and this is what we're going to be doing. We're going to be building on top of this with different paths and different data points and also different HTTP methods. Now let's go ahead and create a module for our actual API events. So inside of our SRC here, I'm going to create a folder called Simply API. Inside of that folder, I'm going to go ahead and create another one called events. And then inside of there, we're going to go ahead and do routing.py. So what I also want to do is make sure that each one of these things has an init file in here to turn events into its own Python module so we can use dot notation appropriately, as we'll see in just a moment. The idea here is we want to have very specific routes for our events resource. So if you think of main.py, this is kind of generic routes. What we really want to have is something like /API/events, and then that being all of the events stuff that's going on in here. So very similar to main.py, but just slightly different in the way it's termed. So let's see what that looks like. So we're going to go ahead and do from FastAPI. We're going to go ahead and import API router, and then I'm going to go ahead and declare router equaling to the API router. Now this router right here is basically the same thing as the app, but it's not an app. It's just for this one small portion of the larger app. And so in here then, I'm going to go ahead and do router, and we'll go ahead and do .get, the HTTP method of get, which we'll see in just a moment. And I'll just put a slash here, and then we're going to define, and this is going to be something like, get, or let's say read events eventually in here, that we will have some sort of more robust response. And I want to return back, let's go ahead and return back in a dictionary of items, and I'll just go ahead and say 1, 2, and 3. Now, the data that's coming back we'll definitely look at and change over time, but for now we'll just say read events like that. So in order for this to work, what we need to do is we need to bring it into main.py, because right now the actual FastAPI application doesn't know about this routing module because we have nowhere, it's not imported anywhere, right? This right here has all of the definition that we have in place at this point. So the way it works then is we need to import it from API. So we'll go ahead and do from API, and then the fact that it is a Python module, because of this init, we can do .events like that. And then I actually can also then go one more dot notation and import routing, and then we can import the router that comes in, and then we can change it as something like as event router. Now, the reason that I do as event router is so that I can just revariable name this, if you will, so that I can have a lot of different ones with the same sort of organization or the same sort of setup that we might have had before. Now that we've got that, we can come in to our app itself and we can use .include router and we can just pass in that event router. But as you recall, the event router itself has a slash here, but we really want this to be /API/events like that. So this is the prefix we want to use for this route. Now, of course, the way I can actually use this path is I could set it right here, and that would generally be okay. It would technically work. But what I actually want to do is go back into main.py and set the prefix itself to that actual prefix without the trailing slash. Okay, great. So that is now an API endpoint route that we can use. Of course, we still need to test these things out, and we will. But before I go much further, I will say that this dot routing is something I actually want to change. The way we change that is by jumping into init.py, and in here I can do from dot routing import router, and then I can just go ahead and export it by putting it into this all list, and we just put in router just like that. Notice it then gets highlighted, and now I can just come back into main and I can get rid of dot routing and just import it that way. It's just a subtle way to do that. It's a nice thing that those init methods are able to do. Now, the init method in here, I could probably also import that router in this init method as well. I don't want to do that. I just want to keep it like somewhat isolated from each other or somewhat packaged in this way. But now that we've got this router, what we can do, of course, is jump into our API endpoint and just check it out by going API and events. And there we go, items 1, 2, 3. Since we have this API endpoint, let's go ahead and create a notebook to verify it. So I'm going to go ahead and do one-verify router, or let's say API event route, something like that. IPython notebook will bring this in here. Now I'm going to go ahead and continue to number the notebooks themselves so you can always reference them later. But the idea here is we want to do something very similar to this hello world where we're going to go ahead and import the requests here. So let's go ahead and open up new code. Then we're going to go ahead and bring in all of these endpoint stuff in here so we can do some various tests itself. Now I want to run this with Shift Enter. It's going to tell me what environment I want to select. Again, we're going to use our local virtual environment, and then our endpoint, our actual path, is going to be a little bit different than this. And that, of course, is going to be API/events. And we can have a trailing slash in here, and then I can do my response equals to requests.get, and then that path itself. Now, the .get method here is correlated directly to this get method right here. We'll talk about that more in a little bit. But for now, I'm going to go ahead and run these two things. And what we should get is the actual API endpoint. But of course, I did path, not endpoint. So that's a slight little mistake. So we need to change it. And then that gives us back a OK response, which we can now print out with response.ok, and there we go. We got a true value there. So what we can do then is say something like if response.ok, like that, we can actually print out the data that's coming from that response by doing response.json like that, and then we can print out that data. Okay, so we hit enter, and there we go. We got items 1, 2, 3. Now the reason we're doing response.json is because this is now a dictionary. So if I actually do type of that data, we should see that it is a dictionary itself, right? Oh, this is not dot, but rather comma. We can see that the class is a dictionary, which in other words means that I should be able to do something like data.get items and do the dictionary value stuff that you might want to do. Now, of course, if we change our API endpoint, this might have some issues in here, as in items might be none. So if we actually did change our API endpoint, let's change it real quick to being, results, something like that. Slight change, made it happen real fast. I refresh in here. This is still the same data because I didn't actually do the request again. So I didn't actually hit the API endpoint again. Now when I do hit it, it gives me something a little bit different in terms of the actual data that's coming back. So this is one of the main reasons why it's really important to think through all of those API endpoints in the beginning, you want to make sure that these stay basically the same going forward. That's why we're going to be testing them out first to make sure we've got exactly what we want. Then we can always, of course, improve it later. But something as simple as just returning back results here could have a drastic effect on somebody who might want to use your API itself, even if that somebody is just you. Let's keep going. We want to take a look at the impact of data types on our REST API. Now, what we saw in the last part was when I changed the key value of this data from items to results, the actual notebook itself had a different result altogether. And so I actually copied that notebook and just made it into 1 or 2 cells here. What we run now is we can see that result still. So what I want to do though is I want to take a look at how this impacts a single API result itself. So in other words, I'm going to go ahead and copy this, and we're going to call this, instead of read events, we'll call this get event, like a single event itself. And then we're going to return back what that single entry might be. So if you think of this in terms of a single row, and this being a list or a bunch of items in a table. More on that soon, but the idea is we want to look at this single row here. Now the way this works is we put in something like event ID. So this is going to be a variable that's going to be passed after that endpoint here. That variable will then come into the function itself. So whatever you name that, you put it in here. And of course, if you declare it as a data type like int, then it's going to look for a specific number. We'll see that in a second. And then of course, we can return back the ID being that event ID. Okay, so back into this new notebook here, I'm going to go ahead and pass in, let's say 12 in here, for example, and I'm going to go ahead and run this, and what I should get back is exactly this data. It's still a dictionary, but it's now returning back ID of 12. If I change it to something like A and then try to run this, I get nothing back. In other words, I can print out that okay, and then do response okay, and I see that it's not okay. And I can also open up the URL itself, and we see that it says unable to parse string as an integer because the input was A. The URL, everything like that, we're seeing that the input is A. So there's a couple ways on how we can solve this. Number one, we could change this back to being an actual number because it's an invalid request. Number two, if we did want to support an A, we would change this from an integer right here, a very specific data type, to string, which is a little bit more generic in the sense that we can then, now support that API endpoint for that string. Now in my case, I want to keep it back as an integer because that's how we're going to approach this endpoint itself, which it requires it to be an integer all across the board, which means then our notebook will also require that as well. But we're not quite done yet. That's the input. That's the data coming through. What about the data going back? Like what if I change this to being ABC ID and run it that way? What we end up seeing here is we will actually still see the data come back. And in some cases, let's make sure we save that and then run it again. And there it is. Now, this is now the output data. It is now incorrect. So we need to change that to something different. That something different is going to be called a schema, which is basically just designing the way the data should flow. In this case, we're going to be using Pydantic. So we'll go ahead and create schemas.py, and I'm going to go ahead and do from Pydantic. We're going to import the base model, and this base model is going to help us a lot. So if we look back into our requirements.txt, we did add Pydantic in here. Pydantic itself most likely will be in with FastAPI as well. So we're really just using the basics of Pydantic here, and we're going to go ahead and say the event itself is going to take in that base model, and this is where we're going to design how we want it to be returned. In this case, we're going to do an ID, which has an integer. So that's the schema that is going to be used. This is also a lot like data classes, but it's going to end up turning into something along these lines where it's a dictionary that's coming back. So that's kind of what's expected by this schema. Now, the way this ends up working then is back into our API routes. We can import that schema. So from .schemas, import the event This is probably better than calling it event. We would call it something more like event schema. So let's call it that. You could call it model, but we're not going to, and you'll see why when we start using the database stuff. Database models is how I typically call models. Schemas, like the design that might go into a database model or come from a database, I'll call schemas. Okay, nevertheless, we now have this event schema in here, and it's in here as well. Now what we can do is we can actually just return that data type. So if the colon and then the int is how we declare the incoming data type, this arrow and then the data type is how we declare the outgoing data type, the response data type itself. And so as soon as I do this, what I should probably see inside of my FastAPI application, or at least very soon, I should see some error with that data type. Okay, so let's go ahead and do a request here. And I'm going to go ahead and run it in two places. So I've got my notebook here and then my FastAPI application running below. As soon as I run that, I see that it's missing the response ID field required. The input again is ABC ID of 12, so the input's incorrect. So all we need to do then is change our route itself, and that is going to be, of course, ID, or basically to match that schema from before. And now we can run everything again, and this time it actually ends up working. Great. So now we've actually made our system a little bit more robust. It's a little bit more hardened because it's harder to make a mistake now, or that mistake will be a glaring problem here. So if I put in IDD, that is possible you make that mistake on accident, but as soon as you go to try it out, you'll get that same error. Like, what is IDD? Don't know, got to fix that, and we'll go back. Okay, great. So then we bring it back just like that. Cool. So of course, solving errors also comes back to using something like Git. So tracking the changes over time will become important if you were using something like this. If you're building out a REST API, of course, you're going to want to use Git. I'm actually not covering that because it's outside the scope of this series, but it is something important to note right now because Git would help identify that problem, because then you could just do something like git diff and of any sort of thing if it was already in your database. So let's take a look at that right now, or rather in your data itself. So I'm going to go ahead and add it, and we'll go ahead and do something along the lines of the actual name itself, which I believe I called it. This will be something like 5, and we'll do basic data types. There we go. And so now I'm going to go ahead and do that slight little change here, save it, and now if I do git status, I can see that there was a change, and now I can take a look at that difference, and what I should be able to see, not schemas, but rather the routing itself. So git diff of that, I now see exactly the problem that's coming through. So this would be another way to catch it, and hopefully catch it early on. Of course, you can also use automated testing using something like PyTest to actually catch that as well, which would be even better to harden the system. But the point here is we now have a way to validate a single piece of data. How about a list of data? Let's take a look. Now that we can return reliable data for a single item, let's go ahead and look at how we can do it with a bunch of items. So there's a couple different ways on how we could think about doing this. One of the ways would be to do something like this, where we just bring back a list. You can just use the list element just like that, and then put brackets there and put in that event schema. That is a way to return back a list, but that actually changes the result schema from a dictionary to a list. So you can't exactly do a dictionary like this. That's not really how it works. So what we would end up doing is we would actually bring in a whole new schema for the results themselves. So what I would do then, and here is inside of schemas.py, I would do something like maybe the event list schema, in which case this is now going to be results of the data type itself, which will be a list of schema. Right? And we could also bring in the other class from typing. So we can do from typing, we can import the list class, and we can use that instead of the list element. So this is a better data type declaration itself instead of doing the Python built-in list. Both work, but this one is more verbose. Okay, so now that we've got this, we're going to go ahead and bring it back into our routing, and we'll go ahead and use that list event schema here, and we're going to go ahead and return back that list event schema, and just like that. We don't need to change it at all because inside of this schema, we've got this results here. Great. So the actual result itself, well, let's actually take a look at that one as well. So if we save this, I'm going to go ahead and duplicate this basic one, and now we'll do list data types or something like that. We'll go ahead and come in and change this to simply events, and we will update this, and let's go ahead and run it now, and we get false once again. Okay, so if I open this up, I get an internal server error, and what's likely happening is the actual input is incorrect. So each one of those items has invalid input data itself. And that's because the actual data that's coming through in here is not an event schema. So we would actually want it to be at least of that type of event schema. In other words, it needs to look closer to this for each instance in here. The way we do that then is actually turning these into dictionaries themselves. So ID equals to that ID, and then we would just repeat this process for each element, which I'm just going to go ahead and do really quickly. And of course, I probably could have just copied and pasted, but there we go. So now the results are dictionary values, and we can see if that solves the problem for us. It looks like the application rebooted, and now we can go back in here and we can run it again. Now the results are coming back. So this is actually super nice. So that means that our routes themselves are now hardened to what we want for our results. And of course, if we wanted to add something to this list schema, say something like count, and we'll go ahead and do count being something like 3, right? Then we would go back into our event list schema, come in here and say count, and this is going to be an integer in here. We could also have it as an optional value, but we'll just leave it in there just like that. And then we'll come in and run this again. And now we're getting false once again. So let's see, for instance, we don't have the results coming back correctly. So let's go back into the route. We've got our count in here. This actually should work just fine. Let's make sure that everything's all saved up. And let's try that once again with it all saved. And there we go. So now we've got the data coming back. Here it is with that count in there. So the point of this, of course, is to make sure that how we're designing our API when it comes to communicating the data is going to be very hardened. It's not going to change a whole lot altogether. So, of course, this is going to be even better when we start entering this data into the database and also actually grabbing the data from the database. But before we even start grabbing the data from the database, we need to learn how to send data beyond something like the URL route. In other words, we need to take a look at the post, put, and patch methods to see how we can send data to our API. Let's take a look. Up until this point, we've been using the HTTP GET method. This becomes even more obvious when you look at something like requests.get, and then inside of main.py, we've got app.get, and then we have a URL path. And then in routing.py, we have router.get. So the get method is very, very common. So we've got get like this. We've got get down here for like some ID. Those methods are what you'll use to grab data from the database or from your API itself. And so our notebook is really just a small example of that. This notebook is really meant to be like as if you were building out another app to work with the API we're also building at the same time. But now what we need to do is we need to be able to send data back to any given server or to our API. So what we want to do is we want to use the post method. That's what we're going to now, is we're going to use that post method in here. And so the idea then is we've got our endpoint. All of that stuff can be the same. To change the response here, all we need to do is change this to not get, but rather post. So now this is going to attempt to send data. But in this case, it's actually not sending any sort of data at all because we didn't define any data to send. So if we actually look at the response itself, so I'll go ahead and do response.text, and we can see detail method is not allowed, as in the HTTP method is not allowed. If we do get, and we see that as well, we can see that it actually unpacks two different things. So we'll look at this as well in just a moment. But the idea here is going back into the post method, we get a detail not allowed. That not allowed error is because of our routing here. So we don't actually have a route to handle the HTTP method. The only routes we have right now are to handle get methods at these particular endpoints. If we want to handle a post method as well, we can just duplicate our function here and then just change it from router.get to router.post, which is now going to be this. as in send data here type of thing. And then this, instead of read events, it will be something like create event. Now, the important part to note is the endpoint is the same as each other, but the method is different. So inside of FastAPI, we create a different function to handle the different HTTP method as well as the different HTTP route. Sometimes what you'll see on APIs is something more like this, where it's create, and it's quite literally a different route as well to handle the different method. Now, that is not nearly as common in the case of creating data. So we're going to go ahead and leave it in as this right here. So we're going to get data. This is going to be more of a list view. This is going to be more like a send data here or a create view, right? And so let's go ahead and get data here type of thing, right? So the idea then is in this function, when we go to create an event, the response should be very similar to the detail view, because when we're going to add data into the database, what we could return back is, hey, we added that data. Oh yeah, and here's the data we added. Because if we modify things inside of this function, which we might, then we want to send back whatever that modification would end up being. So in my case, I'm going to return back the original event schema, and we'll just go ahead and say, we'll just do an arbitrary ID here because we don't actually have a database that will help us with that ID just yet. Okay, so we're almost there. Now that I've got the actual endpoint, let's go ahead and try it again, because now the method should be allowed. So let's go ahead and run it again. And now I get the method being allowed, and then the response is just echoed back in here. So the post method is basically the same as get method at this point. It's just echoing back some data. But that's not what we want to do. We want to actually send data here. We want to actually see some data. So I'm going to go ahead and say data, and I'm going to put this equal to an empty dictionary in here. And I want to actually print out that empty dictionary, or rather data dict equals to empty dictionary rather. So I'm basically declaring the data type and then an empty dictionary in here. So we want to see what that data is. And so this is actually very similar to what we saw down here, where we passed in an argument into the route, a wildcard, if you will, into the route. It's very similar to that, but slightly different. Okay, so let's go ahead and take a look at that, and we'll do this by sending that event again. And if we look in here, we see that there is no data coming through. So there's that dictionary. Okay, so if I actually want to send data though, I need to change things a little bit. Before I do though, I'm gonna go ahead and jump into the response and grab the headers that are coming in here. And so what we see is a bunch of headers, but the important part is the content type here. So what's happening on the server side in our FastAPI application is expecting a certain data type to be sent, especially with sending out data. In other words, the data itself is going to be a JSON data type. So I'm going to go ahead and say something like our page is equal to, test plus or something like that. So that's the data we're going to send now. And we're going to go ahead and say data equals to data. But there's a caveat here. So if I actually run this now, I will get an error, right? So it says the error there. And of course, I can say something in here, something like else, print out the response.txt so we can see what's going on with that response. And what it shows me is input should be a valid dictionary. And here is the actual input that was sent. So that is not JSON data. We can know what JSON data is in a couple of different ways. So one of the ways we do this is by bringing in the JSON package that's built in to Python itself. And then we can do json.dumps and put in data there, hit enter, and now we see this string in here. This is actually quite literally a string, which you can check by just putting type around it, and you can see that as a string. It's no longer a dictionary like what we have up here. So in other words, this is string data, but it's in a very specific format. That format is, you guessed it, JSON data. And so we can send this data now to our backend. So let's go ahead and try that. So I'm going to go ahead and use, instead of just pure data here, I'm going to go ahead and grab this JSON dumps, pass that in, run it now. This time I didn't get that error. It actually did send that data in, and we can actually take a look at that data with this right here. So what ended up happening is this data was treated as JSON still, even though I didn't tell it to treat it as JSON. So one of the other things that you do every once in a while is you create headers and you declare what the data is that's coming through. In this case, it's application JSON. this is not the only kind of data. So for example, if you were sending a file, like an image file, you would not use application JSON. You'd use something different. But the idea here is you can pass in headers in there as well and send that same data. These headers are going to send to our backend. Our actual API will look for those headers and be like, okay, cool. I see you headers. You say application JSON, so it can treat this data as if it were JSON. But in the case of FastAPI, it actually unpacks that JSON data for us and turns this into an actual dictionary, which we can verify by coming in here and saying type of what that data is. And then we can come through in here, send that, and there we go. We've got a dictionary in here. So in other words, what's happening here under the hood, this is all happening for us, but we still need to understand what's going on. When it comes for APIs communicating with each other, it's usually through JSON data. It's not always, there's other data types that you can pass, but it's usually through JSON. So FastAPI was designed in a way that said, hey, when we get post data, we're just going to expect it to be JSON. So then we can just infer that the data that's coming in is going to be a dictionary. In other words, I should be able to respond with this data, assuming I did it correctly. But of course, the schema that I have set up won't allow for this data to respond as an echo. So I'm just going to get rid of the schema for just a moment so we can see the echo come through now. So with data test, I'm going to go ahead and run this all again. And now we should see that echo coming back. As soon as I bring that schema back, it is going to run an error, as we'll see in just a second. So if we run that back, everything's saved, run it again. What I get is now an error because the schema is invalid. So we need one more step with our data, and that is going to be an incoming schema. In other words, this can't be generic like this. It needs to be something else. So for now, I'll leave it like that, and we'll look at that incoming schema in just a moment. Now, I will say one of the cool things about this as well is we can go even further. I can copy this router here, down here, and we can grab something like put, as in we are going to go ahead and update this data. Now, I'm not actually going to cover patch, but put is very similar to this, where we have the event ID coming through, and then we also have the actual data that would be coming through from the backend. This actually would be not called data, but rather payload. That's what we would end up calling it for the put events. So we'll see this one as well, but in this case, we are just returning back this here, and this would be something more like update event. Now, in the case of an analytics tool, I don't know why you would be updating the event directly instead of just entering a new event, but this is kind of what we need to understand is these different methods. Now, there are other methods as well that I'm just not probably going to implement for a bit, but one of them being like delete, where you would delete a specific event itself. That would be another one that you might end up using. Once again, we're not going to be implementing that just yet. But now we want to actually validate the incoming data to our API. We need to ensure the data that's being sent to our API is correct, or at least in the correct format. So very similar to when we send data back needs to be in the correct format. In this case, it's the event schema. We need to make sure that the data that's coming in is in the correct format, not just in the correct data type. So not just a dictionary, for example. So what we want to do here is create a new schema that will help us with this validation. Now, we already saw some elements of this validation with the get lookup where we said event ID is an integer. We want to make sure that it's only a number of some kind. You could obviously change it to being an str, in which case that actually sort of breaks this endpoint where it's now a wildcard. It's no longer an actual number. So we want to keep that one as an integer. The same sort of concept exists for our create event as well. So what we want to do then is we want to jump into our schemas here, and I'm going to go ahead and create a brand new schema. This one is going to be called our event create schema. This one will no longer have an ID in there, but rather it's going to have a path in here, which for now we'll just leave as a string value. And so this schema itself is now going to be brought into the router in here. So we bring it in just like this. I'll go ahead and pass it in here, and we'll do something along these lines right here. There we go. And so now this is going to be our schema. So this is the data in here. All I can do is bring it in as create event schema, or the event create schema. And then I would want to actually rename this to simply payload. You could keep it as data. You could keep it as a whole lot of things, but I actually want to keep it in as payload. I find using the term payload to be a little bit better than data. Data is a little bit too generic for what this kind of data is. Payload is what's being sent to us, right? It could be correct data, but realistically it's payload, just like what we started talking about down here. Now, the other thing is with the put method, we could do the same schema if we wanted to, or we could expand it if we wanted to add something different. So let's say, for instance, we came in here and did the event update schema, and instead of updating the path, maybe we just update the description, and that's literally the only field that we allow to be updated in an event update schema. And so these are required and the only fields that are changing. So what that means then is I've got 3 fields here that the event could potentially save. That is going to be these 3 fields right here, right? So we would have ID, we would have path, and we would have description. So this is what would actually be stored on the database, where the actual endpoints are only supporting these items in here. But the actual event schema, the final one, might have all of them as well. So we'll talk about that when we get to the database stuff. But now that I've got both of these, I'm going to go ahead and bring that one in as well. And we'll bring it in to the update portion also. So let's go ahead and do that just like that. Great. And this time I'll just go ahead and print out that payload also. So I want to see these 2 events and see what they look like. Going back into send data to the API, this notebook here, I'm going to go ahead and run this. And what we should get back is we've got an issue here for our input, right? So we've got page in here and the input saying page, field required being path, not page. So that means that I need to change this to being path, or I need to change the other schema being page. So I'm actually going to change the schema because maybe I don't want it to be called path. Maybe I want it to actually be called page. And so in which case I would save it like that. And then we go back into the API call in the notebook, and now it actually sends it back to us, which is great. So of course we could always echo the data back as well if we wanted to by sending or updating the event schema payload altogether. We'll look at that in just a second. But what I actually also want to see is this update view on how that might work. So going back in here, we'll go ahead and copy some of this data here, paste it below. This time I'm going to go ahead and grab the endpoint stuff, and it's going to change slightly. Which it will be this down here. And then we'll say this is 12 now with a trailing slash because of how our endpoint is set up. And so there we go. And I'll call this my detail endpoint. So detail endpoint and then detail path. And we probably don't need this base URL anymore. And then we'll go ahead and put this down here. Now you might be wondering, what method do we use? Hopefully you remember, it's simply the put method. That's it. Okay, so now that we've got this, there's one other thing that I can do in here that's actually really nice. So instead of doing data equals to JSON dumps data and then the headers, I can literally just use JSON itself. Python requests will then implement all of those other things for me. And what we said was description is the value that we need here, in which case I'll just say hello world. And then now this, of course, is an HTTP put. I now can run this and I should be able to see that it is okay. And if I look in the terminal of our application running, I see there's the description, hello world, and there's the page. And of course, back into the route, this is not a dictionary now, but it's rather a schema. So if I wanted to get this stuff, I could go ahead and do payload.page. And then in here, it would be payload. What did we call it? Maybe that one was page. Yeah, so that one's page. The other one's description. So this is payload.page, and this is going to be payload.description, giving us the full advantage of using Pydantic in our API. And so back into the notebook itself, if I run that again, I see that it says hello world for that description. And then the other one should probably say something like the path itself. So let's go ahead and run that again. And there it is. Cool. So we now have the routing and the schemas for incoming validation as well as outgoing validation to ensure all of that stuff's working. With Pydantic, we can have optional fields. At this point, we don't have any optional fields. We've got only required fields. So let's see how we can actually create these optional fields. Now, before I do, I want to actually update my notebook here a little bit so that the create endpoint and the update endpoint are basically one cell by themselves so that there's no issues with it. And so the create one is going to be here. I'm going to just change this to create endpoint, and we'll go ahead and put that there. The data will actually turn this back into JSON data, and we'll pass in the dictionary with the page of, /test plus or whatever. This is mostly so we don't have any conflicts with some of the variables that might come through from the different responses. And then also we only have to run each one of these one time, right? So get, update. Great. So now that we've got this, let's go ahead and add in the optional data here. So jumping into our schema, what's the optional data I want? Is in this event schema, I probably want to have page and description optional. I'll start with just simply page. And so the way this works is if we put it in as page:string, that is required data. If we want to make it optional, we bring in the optional class from typing, and then we actually bring in the square brackets like this. Now it's optional, or at least seemingly optional. So let's go ahead and save everything, jump back into our notebook, and then run it. I get an internal server error. So if we actually take a look at that server error, what we'll end up seeing is the field is required, right? So it's now still assuming that that field is required. So it's not quite optional yet. So let's go ahead and add in a default value for it. So it's almost optional, just not quite there. My default is going to be just an empty string here, just like that. So let's make sure it's saved. And once again, back into our notebook, we'll go ahead and run that post. And this time it seems to have worked. And there we go. Okay, so what I want to do is actually echo back that response. I want to see that data. I don't have an error anymore with that field, but it doesn't seem to be showing up much, right? So if we look in here, we've got the response coming back. Let's actually take a look. The response coming back is page being an empty dictionary. So that's actually kind of nice in the sense that, yeah, cool, the page is there. If we look at the other one, same thing. The page is there. It's empty. Great. So what I want to do then is I actually want to return back the page data, at least from the first one. And the way we do that is by jumping into routing and then putting in the page data in here. And we can do that with the page value being added to the response value. So payload.page. We save everything like that. We go back into our notebook, we run it again, and now we can see that page value is coming through. And now it's technically an optional value for this field, right, for that data. And we can do that same thing again with the description itself. And we can come in here just like that. And now we've got some optional values in here. And if I look at my requests, there we go. And we can come in and we see all of that. Great. So of course I want to echo back the description back here as well. So back into our routing here, we've got our payload down here, which has our description. And then I can do something along these lines where it's payload.description. Great. So this will help us with that echoing, and of course we can verify that again, and there's that description coming through. Of course, it's just echoing what's ever here, and that's that. Okay, so in the long run, of course, these schemas would be tied into what's happening in the database. So in the middle of all this stuff would be sent to the database and then receiving stuff from the database. But the other thing about this is the actual payload itself, we can actually return it to be a little bit easier on ourselves. So now what we could do is do data being payload.model dump. And what this does is it takes the payload and turns it into a dictionary, which is basically from Pydantic itself, has that model dump, right? And it used to be something different. I think it was like toDict maybe, like this, if I remember correctly. But now it's just simply model dump, in which case this is now going to be a dictionary in here, which I can unpack just like that. And I would do it also down here as well. So we would unpack it like that, and then the data just like that. Great. We probably don't need those print statements anymore, but now we've got the data coming through as we probably want. Okay, so once again, I can verify these in my notebook, and I should be able to see the echo data coming through in here. And one of the questions, of course, would be, oh, well, could I actually send the description now if I wanted to? So if I come in here and do description and set something like, ABC123, will that respond that data back? And the answer right now is no. Hopefully you understand why at this point, but let's go ahead and go through it. First off, the data that's coming through is just this payload right here. It's going to ignore that other data. If you pass in more data in here, it'll just ignore it. There's probably a way around that, as in it will then say, hey, you have too much data. There's probably a way to do that. But for us, we really just want to make sure that we're grabbing the correct data. And so I can actually come up here and give that same optional description in here. And also in the update view, if I wanted to be able to update the page, I can do that as optional as well. But there we go. So now that we've got the description coming through, I should be able to echo that back as well. And there it is. It's now being echoed. And now I have a way to change the responses really quickly. And it all has to do with these optional values if you wanted to add in optional values. Now, every once in a while, you might want to add in a default value. This default would be then using a field. So you'd come in here and say something like field, default being an empty string, or my description, something like that, in which case you would come back into the API. Let's go ahead and get rid of the description I passed in. And now we'll take a look at it. If I run it again, it now gives me that default value if you wanted to put one in there. And of course, there's more verbose ways and more robust ways we can continue to modify that stuff. But overall, this is actually really nice because I have the ability to change all sorts of things in here for my schemas. And now, once again, adding to that stability to how we end up using Pydantic inside of FastAPI. Our API now has the ability to handle different HTTP methods like get and post at different API endpoints, like our list view or our detail view. Now, once we actually can do that, we also see that we can validate incoming and outgoing data. Now, a big part of the reason I showed you schemas in this way, like with multiple parts, is because the way you use different data pieces might change depending on your needs for your API service. When it comes to an analytics API, do we really want to ever update it? Maybe, maybe not. This is going to be something you'll decide as you build this thing out more and more. The point here, though, is we have a foundation to move to the next level. That next level is going to be using SQL databases to actually store the data that's coming through and be able to handle it in a very similar way that we've been doing. And the way we're going to do that is by using SQLModel. If you look at SQLModel's documentation and you actually take a look at how it defines a database table, it looks like this. This hopefully looks very familiar to what we just did, and that's because SQLModel itself is based off of Pydantic. It's also powered by Pydantic and something called SQLAlchemy. SQLModel is definitely one of the latest cutting-edge ways to work with Python and SQL. SQL, of course, is designed for storing data. It's designed much better than Python would be. Python itself is not a database. SQL is. And so we're going to use SQLModel to actually integrate with a Postgres database called TimescaleDB and another few packages to make sure that all works really, really well. Let's take a look at how to do that in the next section. In this section, we're going to be implementing SQLModel. This really just means that we're going to be taking that Pydantic schema validation for validating that incoming or outgoing data, and we're going to convert that so that it actually stores into a SQL database. SQLModel will do all of the CRUD operations. That's create, retrieve, update, or delete of that data into that SQL database. Now, the SQL database we're going to be using is Postgres. Postgres is one of the most popular databases in the world for good reason. One of the reasons is the fact that it has a lot of third-party extensions to really pick up where Postgres falls flat. One of the things that Postgres doesn't do very well is real-time analytics or just a lot of data ingestion. Postgres doesn't do this natively by itself, in which case Timescale picks up the slack in a big way. So we're going to be using Timescale because we are building an analytics API, and this is designed for real-time analytics, and it is still Postgres. So at the underlying technology, how we're using SQLModel is going to be the same regardless of which version of Postgres you use, especially in this section where it's really just about using SQLModel itself. We will use the advanced features that Timescale gives in the next section. This section is really just about understanding how to use SQLModel and actually storing data into a Postgres database instead of just using Pydantic to validate data, because that doesn't really provide that much value. Let's go ahead and dive in. On our local machine, we are going to be using Docker Compose to spin up our Postgres database. We'll start with the configuration for pure old Postgres, then we'll upgrade it to Timescale. And all of this is going to be done using Docker Compose in just a moment. Now, if you skipped Docker Compose, you can always log in to timescale.com and get a database URL and just use the production ready version right in there. That process we will go through in the next section, but for now, I want to just do the Postgres one on my local machine. Now, a big part of this is looking for the Postgres user and all of the different environment variables that are available. So we've got Postgres password, user, and DB. Those are the main ones we want to look at to get our local version working inside of Docker Compose. So I'm going to open up compose.yaml here, and then we're going to go ahead and tab all the way back. Make sure it's on the same level as app. One of the ways you can figure this out is by just breaking it down like that, and then you can do something like DB. We'll call it DB service in here, and then I can go ahead and create those things out. With this still broken down, having it broken down makes it a little bit easier to know exactly what to do. Now, the first thing is we can come in and decide our image. So if I were to use Postgres itself, I would come into Postgres official, and then I would want to look for the tag that I'm going to end up using in here and be very deliberate about the tag, especially with Postgres as a database. So maybe you use 17.4 bookworm or just 17.4. The size of them looks about the same, so it really probably doesn't matter that much between the two of those. So you could do something like this, Postgres 17.4. Next up, you would want to set the environment, which will be all of those environment variables. So once again, searching for that Postgres user in the documentation on the README. So let's go back a page here and search for that. And you can actually see the different environment variables. So you'd come in here and do something like Postgres user, and then the next tab would be Postgres password, and then something like this, and then the actual database itself. The core values here are basically this, right? So those are the key ones that we're going to want to have. Next up, what we're going to want to do, and this is one we will definitely need, is something called a volume. This volume is going to be managed by Docker Compose. We don't manage it ourselves. It's not quite like what we did with our app where we actually mounted the folder here into the container. Instead, we're going to let Docker Compose manage the volume itself. So before I even declare that, I'll go ahead and do volumes. And this one, I'm going to call this my TimescaleDB data. And just like that, that's all you need to put in. And then you can use whatever you name this, and you can bring it up to your volumes here and then have it go to a specific location, which in the case of the Postgres location, the Postgres database, it's going to be var lib Postgres SQL and then data. And so that allows your Postgres instance on Docker Compose to persist data, because you definitely want to have that. So if you take down this or run Docker Compose down, all of this will still be up and running. So similar to like our app itself, we also want to declare the ports in here. And I'm going to go ahead and use the default ports, which is 5432 and then 5432. And then in some cases, especially with what we're going to be doing, you might want to expose the database, which is going to be 5432. I'll explain that when we start to integrate this into our local project here. Okay, so the idea with this is using Postgres, of course, right? So if we actually scroll back into Postgres, there's the name of it, all that. It's all good. We could totally go that route. But I actually don't want to use Postgres. I want to use Timescale. So Timescale is not a whole lot different, but the thing is we grab this right here. So now it's going to be Timescale. That's going to be the repo name or the image name. And then we grab the actual image tag, which we come into tags here. And we can actually scroll down. Actually, in the overview here, we also see the tags, the notable ones, latest PG17. So in the case of Postgres itself, you got 17.4. With Timescale, we can just do latest PG17, and everything else is the same, which is really nice. But of course, I'm going to change these values in here to something just a little bit different. And I'm going to change the user to time-user. And then we'll go ahead and say time.pw. And then I'll go ahead and do my TimescaleDB in here as the actual database name that I'll end up using. So all of those values are going to allow me to do something like this in my .env, which is going to be my Postgres SQL plus scopg, which we'll go over again once we implement it. But it's going to be our username. So it's going to be just like that. And then colon our password like that. and then at some host value, which we'll come back to, then the port value, which is going to be right here, and then slash the actual database itself. So all of this is what we'll need in our environment variables for our app itself. So the app, we can add it into up here. We could say something along the lines of database URL equaling to basically that data. Now in development, this is generally okay. In production, you're not going to want to have your actual environment variables exposing something like this. So in which case you would use an env file as we discussed before, but that's when you would come in here and go into .env and save it kind of like that. Now, as we saw before as well, when we were doing it with our app, whatever you hard code in here, that's going to take precedence over the env files themselves, which is kind of nice. But there's our database URL, and of course it's based off of all of this stuff. But there is one key component that we still need to change in here, and that is this host value here. This host value is going to be the name of the service itself when you are using it inside of Docker Compose. I'm going to show you how to use it in both places, but I want to leave it like this for now. We'll save this, and then inside of my Docker Compose, all I have right now is my app running, so I am going to need to take this down, and we're going to go ahead and restart our app itself. Looks like I'm having a few issues with our app running, so I'm not sure if maybe it's related to this Docker Compose rebuild. It seems that it is. Now with the app down, I'm going to go ahead and run Docker Compose up, and I really just want to see that our Postgres database is up and working. Our DB service is being created and downloaded and all that. No surprise there. It's actually grabbing it from Timescale, the Docker Hub version of the TimescaleDB. Of course, it's open source, so that's really nice. And I'll let that finish running. Okay, so it finished running and it looks like everything is working in here. We might need to test this out with Postgres directly, but in our case, we're just going to leave it as is and we'll test it directly with Python. But if you are familiar with Postgres, you will want to probably test this. The other thing, I just want to make sure that my app is still running. It looks like it is. So I think our Docker Compose stuff is probably good, and we're now ready to start the integration process within our app itself. I'm going to be integrating it in two different ways. One is by using the Docker Compose version, which is basically this right here. Another one is just considering our database as Docker Compose so that our app itself will be able to run with things as well. So in other words, having basically two environments that can still work with this Docker Compose instance of our database itself. Now, one of the things that's also important to note that we will be doing from time to time is we'll go into the root of our project and we will run Docker Compose down -v. -v will delete the volume as well, which means that it will delete all of the database stuff as well too. The reason we run this, especially in development, is to get things right, to get it working correctly. Then once it is done deleting, we can bring it back up and everything is back basically from scratch. When it comes to development, this is a key part of it, is making sure you can bring things down and bring it back up, and it happens that quickly, which is another reason to really like using something like Docker Compose. Of course, one of the bad things about it is you might delete a bunch of test data that you didn't intend to delete, which of course is something you want to think about if you are going to run Docker Compose down. One of the first steps in integrating our database is to be able to load in environment variables. Now, when it comes to Docker Compose directly, the environment variables are going to be injected. In other words, we can come into SRC here, and let's go into one of our APIs, into one of our routes. I should be able to go in here and go import OS, and then just come on read events, and I'll just go ahead and print out os.environ.get of the database URL itself. And so in which case I should be able to go into /API/events, hit enter, and I should see that print statement come through, and there it is right there. Okay, great. So that's being injected into our application because of this right here. But unfortunately, or fortunately, this won't necessarily work if we bring in our application directly from our virtual environment. So let's go ahead and do source venv bin/activate, and then I'll go ahead and navigate into the SRC here, and then I'll go ahead and run this same thing right here, but this time I'm going to go ahead and not specify the port because it'll give me most likely port 8000. So now I can open that one up and I can go to API and events, and hit enter, the print statement is going to be none. So we need a way to kind of handle both scenarios. Some of you might want to use Docker Compose when you're developing. I know I do a lot of times, but I also know that I also don't do it a lot of times. Sometimes I don't set up my apps this way. So our actual FastAPI application needs to be able to be ready for both of those things. So inside of requirements.txt, this is where we need to change something. I'm going to add in something called Python decouple. Now, there are other ways to load in environment variables. One I think is called python.env, but I like using Python decouple for a reason, as you'll see in just a moment. So the idea here is now inside of my API, I'm going to go ahead and create another folder in here. We're going to call this DB. Inside of DB here, I'm going to go ahead and create that init method. And then I'm also going to create config.py. And what I want to do, of course, is using pip install python decouple. I'm going to go ahead and do from decouple import config. And then we'll call this as decouple config, mostly because this module I just created is also called config. We don't want to have any weird imports in here. Now, as you notice, cursor is saying, hey, decouple is not installed. So we need to make sure that we do have that installed in our virtual environment, which I'll do with that pip install there. I already added it into requirements.txt, so I don't necessarily need to install it again through that. But with this running now, I can reload in here, and now I've got this decouple config in here. So what I like to do is I like to put in our database and URL, and this is going to be equal to decouple config, and that's going to be that same database URL, and the default is going to just be equal to an empty string here. So this is why I like Python decouple, is we've got this empty string here. The other thing about decouple config is it can actually load in a .env file, as in this right here. So we've got this host value here. So now, hopefully, if we did it correctly, we should be able to use this. Now, the way we use it is going to be from our events, where now, instead of using OS, we're going to go ahead and do from .db.config. We're going to go ahead and import the database URL. Or better yet, I think we should be able to do from api.dbconfig, maybe grabbing database URL that way, but we'll see if that ends up working. So let's go ahead and take a look with that print statement now. And going back in here, we refresh, and now we've got none from os.environ, but database URL is actually working inside of here, which is giving me a different host value, but that host value is based off of the .env file. So this actually brings me back to what I would actually do with Docker Compose. I would not put it hard-coded in here, but instead what I would do is I bring in another .env file like .env.compose and use those same parameters in there, and I'm going to just go ahead and put them in directly like that, and then we would use maybe that same port value. It's completely up to us in that term, but we've got this database URL here, and then in compose.yaml, the env file itself would be .compose, and then I would just go ahead and completely get rid of this environment itself. The only reason I'm commenting it out is so that, well, we can actually bring it in as need be. Okay, so what we see here is we got this, no module found error. I think maybe I didn't save something or whatever, but let's go ahead and bring it back up, which should actually build everything, but it's not actually building the Python decouple. So what I'm going to do then is I'm going to go ahead and stop it, and then when in doubt, when something like this happens, you do -- build, and that should actually build the application itself for the ones that are going to be built, which will install those requirements. Now, for some reason, I actually know why this rebuild did not happen, and it's because I did not do Docker Compose watch. So that's something else I need to remember to do, and that is Docker Compose and up -- watch, so that it does rebuild it when requirements.txt changes, so that error goes away. But the key part about this is that now I have another place for my environment variables. If I refresh on the Docker Compose version or my local version, I should be able to see the environment variables coming through for either one, and now I have support for both places. Now, the reason I'm doing this as well is so you get very familiar with the process of loading environment variables, especially as you work towards going into production, because you're going to want to help isolate these things going forward. Now, notice that this .env.composed is underlined, or it's ready to be going into Git. So if we actually look inside of our Git status here, we can see that .env.compose is in there. If we look in the GitHub repo, the actual sent code, we can see that .env is not in here. This is an example of I'm okay with sending this environment variables because compose.yaml is still using them. And in this case, it's really just for a local test environment, one that I consider disposable, as in I can delete it at any time. Obviously, the usernames and passwords are not great here. This also should indicate to you that the actual Timescale service, if you were to want to use Compose in production, these environment variables should also be in an env file and be done differently inside of there if you were using Compose in production, which we are not going to be using at all. We will be using Docker files, but not Docker Compose. Okay, so that's loading in the environment variables in both places. As you can see, Docker Compose is far easier than what you would do, what I just did. But the other thing about this is beyond just having environment variables, if you have any other static variables you want to set, like other settings for this entire project, you could also put those inside of this location as well. Now we're going to convert our Pydantic schemas into SQL models. This is before we actually store it into the SQL database. I really just want to see how the features of SQL model work in relation to the actual Pydantic models. So what I want to do here is grab this schemas, and I'm going to go ahead and copy it and make a new file called models. So realistically, what we're doing here is just updating the previous ones to be based in SQL model, and it's going to be incredibly straightforward to do. I'm actually going to name them the same thing for now. We might change them later, but for now we'll leave them as event schema and so on, mostly for the imports when we go to test this. So the idea here is we want to not use Pydantic, but rather use from SQL model. We're going to go ahead and import the SQL model and then also the field. Okay, so base model is now going to be SQL model. So we'll go ahead and replace all of these in here like so. And I shouldn't have to change the field, but overall, this is like the main change that I'll need to do. With the actual ID, we will probably have to change that later, which you can actually see in the documentation. It's going to look like this at some point. So we might as well put that in there, at least as a comment for now, and then we'll come back to that in a little bit. But what we've got here is basically the same thing as we had before. So inside of routing, instead of .schemas, we're going to go ahead and change this to simply just .models. Then we'll go ahead and jump into our notebook, and we really just want to test to see if all of the notebook stuff is still working. Let's make sure our app is running. I have it running in 2 places, I think. It looks like it is. So inside of Docker, of course, and then in my local machine. Let's go ahead and run this all together, and everything works as it did prior. So we should have the actual models all set up as we had before. Okay, so the big change from here would then be to change this into a table, as in this is what we're going to actually end up storing. Of course, we're not going to do that just yet. The point of this was really to see that SQL model and Pydantic are the same. And of course, if you actually look in the documentation, you will see that at the same time, it's also a Pydantic model. So it's quite literally a drop-in replacement for this. As we'll see very soon, it will also help us with storing this data. Now we need to create our first SQL table, a database table. The way we're going to do this is a 3-step process. The first step is going to be connecting to the database itself using a database engine. When I say connecting, I mean having Python being able to call the SQL table, right? That's it. That's the connection. That's what database engines allow for us to do. After we actually can connect to the actual database, we need to decide which of our schemas in here is going to be an actual database table. That might be all of them, it might be one of them, it might be none of them. But the idea is we need to decide which one's going to be a table and then make sure that it's set up the correct way to be a table. And then finally, inside of FastAPI, we need to make sure that FastAPI is connected to all of that so those tables are actually being created and they're being created correctly. Okay, so the first thing that I want to do then is actually decide which of these are going to be database tables. Now, you may have never worked with databases before, or you have and you just didn't realize how these tables work to make a decision like this. So if you think of a database table very similar to like a spreadsheet, you're on the right track. Spreadsheets have all of those columns, and you can keep adding columns as you see fit. But then when you actually want to store data, those columns describe what data you want to store in that particular column. This is not that surprising. You might have a column for ID, you might have a column for page, you might have a column for description. All of those columns in a database need to have data types. So in the case of an ID, the entire column is only integers, they're only numbers. In the case of a page, those can all be strings. And every once in a while, you might want to have a datetime object, or you might have float numbers, or all sorts of different other data types. There's a lot of them out there. The point is, SQL tables, especially inside of the structure of SQL, have the ability to do very complex operations on all of this data. Now, when you think of a spreadsheet, you might only have a few thousand rows in there at any given time. Maybe you have up to 1 million, but if you got 1 million rows in a spreadsheet, there's a really low likelihood you're going to be opening it up in Excel or something like that. You probably need to use something different altogether. But the idea here is a spreadsheet has limits to the number of rows. SQL tables, on the other hand, basically have no limits, or at least in many cases, they're designed to have massive amounts of data in there. And so having these data types make a huge difference in how we can use those tables. So for example, if you want to get IDs that are greater than 100 or 1,000, the actual SQL table itself will be able to do that very, very efficiently versus trying to go one by one and looking for that specific ID. There's a lot of advantages of using a database itself to store data. I'm not going to go through those advantages. The point that we need to know right now is that our columns need to have specific data types. Now, this is the cool thing about SQLModel is we've already declared those data types: integer, string, string, right? So we already have 3 data types in here, which are going to be actual fields that will be in the database itself, otherwise known as columns. Columns, fields, you can think of them as the same thing in the case of how we use our SQL model. So the idea here then is we want to decide which one of these is going to be a table. Now, this is actually fairly straightforward if we look at how we're using it by going into routing.py, right? You could already have some intuition about which to pick already, but let's go ahead and go through each view to see how we're using it and how this might affect what we decide to store in our database. So if we look at the very first one, we've got an event list schema. This is a get. We are only extracting data from the database. That's it. So there's a really good chance when you extract data, you're going to not store the extraction that you just did. So that kind of is like a circular loop if you were going to store every time you extracted something. That doesn't make sense. Now, you might store the fact that it was extracted, but you probably won't store the actual data that was extracted. So this one, I think the event list schema, we can say, yeah, it's probably not going to be a database table. The next one, create event. Now, the incoming data is what we end up storing, but do we always want to store all of that incoming data? Or do we want to make sure that the incoming data is flexible? In other words, this event create schema here, if we were to change it, let's say, for instance, we didn't want to store a description anymore on that create event, we want to remove that. Do we want to remove this field from the entire database itself? The answer in that case would be no, we would want to keep that field in there. It's just when we first get that data, we aren't going to want to, maybe have that field anymore. Okay, so in that case, this one we're probably going to rule out. But notice that it actually turns it into an event schema. We return back the event schema itself. Now, this is the one we're definitely going to want to store. So we get a payload coming in of data that's all validated and all that. Then we want to turn it into a different data type, which means that we're going to end up storing it inside of the event schema table, which will change very soon. Now, another thing about this is we notice that the event schema itself is used multiple times for database-like things. In other words, if we are looking up that database table, we see event schemas in there. So that means it's probably going to grab data from there. And then also when we go to update data, we've got some data coming in that we might want to change. And again, we can decide which fields we want to actually allow for updating to happen without removing those fields from the database. Then we can actually return back that event schema. So yeah, event schema is the only one we really need to save in here. And of course, the event list view is doing a result of the event schema as well. So that's the one that's going to be our database table. It's going to be this one. I actually do not want to call it event schema anymore. I now want to call it event model. The reason is hopefully straightforward, but let's go ahead and actually modify this a couple times We'll call it event model. And then I want to go ahead and add in here table being true. And then of course, if I change this event model, I'm also going to delete schemas.py. We're just going to use models.py in this to keep it simple. And then inside of routing, we're going to go ahead and do some changes in here because it's no longer event schema. It is now just event model. So all the places that had event schema, I'm going to change to event model. Now, the reason I'm calling it event model is you might as well think of it as event table or event database table. And that's kind of the point here. So that's why I'm going through the process of changing all of the places where it said event schema. And now also when I look at the schema stuff, I can kind of think of those in terms of not being a database table or not being a database model. And that's kind of the point. Now, these could be Pydantic models, but in terms of the documentation from SQLModel, they recommend you use SQLModel itself. There's probably advantages to it that we could obviously look up, but for now, we'll just leave it as is. Now we need to connect Python to SQL by actually creating a database engine instance and then actually create the tables themselves. So inside of the DB module here, we're going to go ahead and create session.py. This will handle something else later, which is why it's called session. But the idea here is we need to create the engine itself. So engine equals to something. And then we need to actually define something that we will initialize the database itself, which would be something like creating database. Okay, so before I actually even create the engine itself, we need to know when we're going to run this initDB stuff. Now, the idea here is in main.py, this is where we will run it in what's called a lifespan method for FastAPI. But before I show you the lifespan method, I wanted to show you the old way of doing it, which is an event. So if you actually came in here and did app.onEvent and something called startup, you could then define on startup, and then this is where you could actually run the init method for DB. This is still a valid method. It still works, but it is deprecated, meaning it's not going to be supported in the long run. So we do something a little bit different than this. Now, if you have these on event stuff, you're going to want to either do all on event or none of them before you do the context method or the context manager method, which is what we're going to do right now. So what I want to come up at the very top, we're going to go ahead and bring in from context lib. We're going to import the async context manager, this right here. And then up here, we're going to go ahead and use that async context manager. It is a decorator, so we'll go ahead and grab it. And then we're going to define the lifespan, but it needs to be an async define lifespan. And it takes in the app, which is an instance of the FastAPI app. So you could absolutely use the FastAPI app in here if you wanted to. This is where we're going to go ahead and call initDB. And then we need to yield something. And then this last part would be any sort of cleanup that you might want to do. So basically like we've got here, let's remove this. We'll go ahead and say before app startup. Then it yields to actually run it, and then we actually can clean up anything in here. Now, I think the reason they brought this in was because of AI models, and with AI models, you might want to run this lifespan thing in here. So it kind of gives us before and after inside of our app, but the idea here is we can pass this in to FastAPI. So that's what we're going to be doing. Now we want to actually bring in that init method here. So we'll go ahead and do from api.db.session. We're going to go ahead and bring in initDB. Now, of course, we actually need the database to work in here. So we'll go back into our session and create this stuff out. So the first thing is going to be our database engine. We're going to import the SQL model itself, not SQLAlchemy, but SQL model. And we'll create the engine by doing SQLModel.create engine and then passing in the database URL string as we see here. So that also means that, of course, I need to go ahead and do from.config. I'm going to import the database URL, and we'll go ahead and pass that in here. Now, the important part about this database URL is it does have a default in here of an empty string. So I want to actually make sure that that's not the case. So we'll go ahead and say if database URL equals to that empty string, then we'll raise a not implemented error saying the database URL needs to be set. Now, the reason I'm defining the engine here altogether is because later we're going to do something called get session, which will handle or use that database engine as well. So now that we've got that, we need to actually initialize the database itself, which is going to be from SQL model Once again, we're going to now import the SQLModel class, and we'll use this class to create everything. So it's SQLModel.metadata.createAll, and it's going to take in the engine as argument. So now what this is going to do is obviously make the database connect to the database and make sure that that database has all of the tables that we've created in the case of table being true. Now, one of the things that it will not do is it will not search your Python modules for any sort of instance of this class right here. That's not how SQLModel works. It only actually creates those tables, these tables right here, when those models are actually being used. In our case, they are being used. In routing.py, we actually have the event model in here. It's being imported. This routing is also being imported into our main application from Event Router. In other words, the actual SQLModel metadata engine thing should actually work now. And so let's go ahead and save everything. If you do save everything, what you might get is an error like this where scopg is not installed, and then you also might get it in both places actually. So what we want to do is make sure that scopg is installed. Right now I don't actually have it installed in here. So of course we're going to do that in just a moment. Now, if you remember back to environment variables, we actually did this plus scopg in here. That's part of the reason that it's looking for it. That's why we've got this error in altogether, is it's looking for that specifically. So what we need to do then is inside of requirements.txt is we need to use that. I'm going to be using the binary version, which is why I put that bracket in there as binary. This is scopg 3 or version 3. There is another one called scop 2, and you would see that, and it would be something like this. I believe that's the old version that you would end up using. So now that we've got this requirements.txt, of course, if you're using Docker, what's going to end up happening is this should actually rebuild everything. Looks like we've got a little bit of an issue going on there. But if you're not using Docker, which I have both of them up for a reason, you would then just go pip install -r requirements.txt and hit enter. This should install all of it. Using scopg binary, I think, is the way to go. It makes it just a little bit easier to run the integration itself. There are other ways to connect it. We'll talk about that in a second, but I just want to make sure that this loads and it runs. It looks like it's loading and running, but I get this error in here. This is another error that we definitely need to fix, and we'll talk about in just a moment. But of course, on the Docker side, it actually rebuilt everything, and Docker looks like it is working just fine. So we'll come back to our local Python in just a moment. The key here, though, is really this lifespan in here, and that it is creating these database tables. Now, we won't know if these are created just yet. We need to solve that one error. So let's talk about what that error is and how it relates to Docker and also using Docker locally. In that last part, we saw an error where scopg was not available. It was not found. And the reason that we saw that error in the first place has to do with how we were mapping in our database engine. So if we look into our session here, we see that we've got this create engine for this database URL. The scopg error happened because of our environment variables with this plus scopg. And we can actually see that in both places, whether it's in our local Python project or in our Docker Compose version of it. So both of these showed us that specific error. Now, the thing about the SQL model, and more specifically the underlying technology, which is SQLAlchemy, is it can use more than just Postgres. It can use MySQL, it can use MariaDB, and there's probably others that it supports. So this create engine here from a database URL is very, very flexible, which is why in our .env, we have to specify PostgreSQL plus the actual package we're going to use from Python to connect, which is why it raised that error, because we never actually installed it. Once we installed it, that error went away, but it brought us a new error, which is related to connecting to that database. Now, this is not really that clear as to this right here. Of course, if you do a search or if you look at this, it will probably show you that there's something with the connection that's failing. And of course, if we look at our Docker Compose one, that one is actually not failing. It is working correctly, or at least it seems like it's working correctly. So the reason that the Python one is failing is because of where our database is coming from. It's coming from Docker Compose, this DB service right here. So inside of the Docker Compose network, which has both of these apps, they can communicate with one another. That's one of the great things about using Docker Compose is there's internal networking inside of Docker Compose, which is why we were able to specify our database URL in this way. So I could say DB service, which is literally the name of the service, and it would be able to connect. It's a little bit different than like going on our local browser, right? So when we go into our browser and look at our app, it doesn't say app here, it says 000, right? So if I tried to do app here, I would get a connection error because that is not how my local machine can connect to this app. It has to be on 000 or my local host, basically. I should be able to connect with simply localhost, or at least I could try to connect with localhost, and that also seems to be working just fine. So the way we connect to our actual database service, though, is a little bit different than the way we would connect to our app itself. Now, the reason it's a little different is the app itself is connecting slightly different than our browser. So if we actually look in the .env here, we see that it says host value. If I change this to localhost, I can try that one and see if that ends up working. As soon as I save it, let me just restart the Python application itself and see if that does it. That seems to do the trick, right? And so if for some reason that was not doing the trick, I want to show you one other thing we could try as well. So let me close this out. And inside of Docker Compose, I'm going to go ahead and get rid of this expose here for a second. We'll save that and we'll run this again, and it's still connecting. So we're doing okay in terms of our ports are concerned. But every once in a while, you might need to go into .env and change it from localhost to being something based off of Docker itself, which is host.docker.internal. So that might not be another environment variable you would need to run in order for your app to be able to run as well. But right now, this is still also giving us an issue. So that is not one that you're going to want to use. You'll want to stick with localhost, just like our application has been using before. So the reason that I wanted to show you the Docker host internal one, so I'll go ahead and leave this commented out right above here. The reason that that even exists is because you might want to try it from time to time, depending on your host machine itself and how that ends up working. So it's host.docker.internal will often be mapped as well. So this is, of course, one of the challenges with trying to use Docker Compose without putting your app in there as well. But to me, I think developing this way is fairly straightforward. But of course, every once in a while, you might need to use a database service that's not inside of your internal network itself. So there's a lot of different things that we could talk about there. But the point here is we need to solve that single connection error. Now, this is also more easily solved by using an actual database that is definitely going to work. Like if you went into Timescale and created a database, you should be able to actually bring in that connection string. It might also still need to use this stuff right here because of how we need to connect, but the actual host and all that stuff, all of these things would then be based off of like Timescale, an actual production ready one that we could then go off of as well. Of course, we will see that very soon, but at this point, now that we've solved some of the database issues, we can move to the next part, which is actually using our notebooks to see if we can actually even store this database stuff, which actually takes a little bit more than just using those notebooks. Let's take a look. Let's store some data into our database. The way this is going to work is first off, we need to create our session function inside of the DB session module. We're going to go ahead and create something called get session here. And then what it's going to return back is with session, the session class itself, which we'll bring in from SQLModel. We're going to go ahead and pass in the engine in here. And then as session, this is going to yield the session itself. Now, the reason we have this is because then we can use it inside of our routes that need a database session. So the idea then is grabbing that get session method. So we'll do from the api.db.session import get session. We're also going to go ahead and bring in depends from FastAPI. And then we'll go ahead and bring in from SQLModel, not SQLAlchemy, but from SQLModel, we'll import the session as well. So all of this allows us to then come into an event like this and say something like session, and this is of the data type session, and then it equals to depends and get session. That's it. So this function right there will yield out the database session so we can do database session stuff down here. Now, the thing about this function now is it's getting a little bit bigger. So I'm going to go ahead and separate things out a little bit. And I'm also going to put up response model up here, just like that. So we don't have to use that arrow method anymore. You could do that on all of them. Both methods are supported and work just fine. Okay, great. So now we've got this database session. I want to actually use my model. I actually want to store things in my model. So the first thing that I want to do is I'm going to go ahead and say object, and that is going to be our event model. And then we're going to go ahead and do model validate of the data that's coming through. So this data right here, we're going to pass into validate. So we're basically validating it again, but more specifically to the model we're storing it with. Then we're going to go ahead and do session.add that data. So when I say OBJ, I think of this as an instance of this model, or basically a row of that class, but I like calling it OBJ. It probably is an old habit. You can call it whatever you like. Just make sure that it's consistent throughout your entire project whenever you're doing something like this, and then you're adding it into the database. So this is preparing to add it. Then session.commit is actually adding it into the database. Then if we want to do something with this object, as in get the ID, we would do session.refresh of that object. And then we would just return back that object itself, because it's going to be an instance of this model class itself. And that's how we do it. That's how we can add data into our database. It's really just that simple. Now, of course, we have to remember that if we want to use a session, this is the argument that has to come in there. We use the session variable through here. If I called this sesh, that would be fine. You would just want to update it down here. That's not common, so definitely consider that when you change these names. But the idea is, of course, it's a session class, and it depends on that function, which will yield out a session based off of our database engine, which is, of course, why I have that database engine up there in the first place. So now that we've got this, we've got a way to actually add in data, which we can verify by going into our notebook and trying this out. So I'm going to restart in my notebook here, and I'll just go ahead and run it. And what we should see is there's some data in here with an ID. Now, do we recall whether or not that ID was valid before? I don't know. Let's do it again. There's another ID, and we do it again. There's another one, and we do it again, and another one. So we'll continuously increment this ID, even though we didn't specify it directly inside of here. All we are specifying on that API request is the data that's coming through, and so it's automatically incrementing it for us thanks to the features of a SQL database. In this case, it's a Postgres database, but we're automatically incrementing with this being a primary key, as I mentioned before, and we can see that result right here when we go through and actually add in more data. Now, of course, we need to fill out the other API routes as well, which we'll do in just a moment. But before we do that, I will say, every once in a while, as soon as you start filling up the database with some of this test data, you're going to want to come in here and do Docker compose down with that -v to take down the database itself. This will delete that database and that network altogether, and then you would just bring it back up with that watch command just to make sure that everything's changing as need be. Now the database is completely fresh, which we can then test again by jumping back into that notebook and running the same commands. Now we get a connection error with the notebook, which doesn't make that, it makes a whole lot of sense with how these sessions work within a notebook. So I'm just going to restart the notebook, and then I'll go ahead and try that again. And I'm still getting a connection error, so that's probably not good. This is probably a little bit of an issue with one of these things. So let's go ahead and restart this application. Which port are we using up here? Let's see here. We've got a 8002. So everything should be back up and running again. Let's see. Looks like the database is ready. Let's go back into the notebook here. And maybe I just went a little too fast for it. And there we go. So now it's back into being connected with that one. Let's try this one here. And there we go. So we should be good to go in terms of the data. And there it is, auto incrementing. Okay, so every once in a while you might need to let things refresh and actually rebuild as well. So saving data and doing all that will help flush out that process, because you're probably not going to bring the database down that often, especially not while you're talking about it. We're now going to ask our database for a list of items, a certain number of items that we want to come back. This is going to be known as a database query that will return multiple items. So the first thing that we want to do is look into read events. This is where we're going to be changing things because, well, that's our API endpoint to list things out. Now, the first thing I want to do is bring in the session because I'm using the database, so I definitely want to have this session in there to be able to use that as well. Now, once again, we can use that same response model idea up here as well, but this time instead of the event model, it's going to be the event list schema, which we, of course, already have formatted out right down here. So the idea is we want to replace this list right here with the actual results. So the way we do this is by doing something called a query. So we set it equal to a query. Now, if you're familiar with SQL, you might be familiar with something like select all, and then from some sort of database table itself, which in our case is the event model. We're basically doing that as well, but we're going to be doing it from the actual event model class. In other words, the actual SQL model ORM, so which means that we need to bring in this select call here, which we will go ahead and do select from this event model. And so that is a basic query that we can do. Then from there, we can actually get the results by executing this in the database itself, which is our database session.execute, and then the query itself. And then the final thing is we would do .all. This would allow us to get a bunch of items in here, in which case I should be able to return them just like that. The reason I should be able to return them is because of this model itself is inside of the list schema also, right? So going back into that schema itself, we see that the results are looking for instances of that model, which is exactly what we're doing here. We're returning those instances in this request. That's what's happening with that. So that's at the baseline what is going to happen. And then we can also grab the length of those results. And then there we go. So this should give us some results in here. Now, if we actually go back into our notebook for the list data types here, I added this pprint statement in here so we can actually see it a little bit better, which allows us to see, hey, there's the ordering that's going on. There's all of that data. Of course, if we were to add in some more data, we can see this again. So I'm going to go ahead and add in a few more items in here and just run this cell several times to just make sure that I have maybe over 10 items in here, as we can see by this ID, or maybe even over 12. So later we can use that 12 number again. So now that I've got 12 in here, let's go back into my list data types and run this again. And we can see there's my 12 in here. So this becomes a little bit of an issue as our results here have 12 items, but maybe we actually only want to return back 10 items, in which case we would come back into routing and we would need to update our query here by having something called .limit. And then we can pass in the amount that we might want to limit in terms of the result itself, in which case I should be able to go in here and then I could run that limit itself. And then there's 10 as a result, and we see that there's only 10 items in here. Now I can also update this so the ordering or the display order is a little bit different as well. So back into our routing here, we've got this query still. We can come in and then do something like .order by, and we can add in an ordering in here. Now, how does this ordering work? Well, it's going to be based off of the actual table itself, which of course that table is our event model. Inside of that table, we have different fields in there. In my case, I can use .id. That field is this one right here. We could use page or description as well, but those are the only fields we can really order this by. And then we can do .descending, which just changes the order. It flips the order in here, which we could verify by going back into our API and doing another request. And we see now it's flipped and ID of 12 is coming up first, and 2 and 1 are no longer in the results altogether. And of course, if I wanted to flip it back, I can change it to ascending. And of course, that will flip back that order with different values in here. Okay, so this would be like, okay, the next level of this would be doing pagination, or allowing to have only 10 results coming back, but then multiple pages of 10. So you can do this request several times to get all of the data, because realistically, you would not get all of the data at once. You would probably never do this command. That's probably going to end up being too many things. So you would often use a limit. You might have a bigger limit like 100 or 500 or 1,000. It really is going to be depending on your API's capabilities. But the idea here, though, is we do want to have a limit of some kind. And by default, you may have noticed that the actual ordering was based off of the ID. It was actually going up like this. It was doing that ascending from the ID, which is also very nice. It's a very easy thing to work with. But that's our list view. Now that we've got that, we might want to make it even more specific, as in getting a detail view, a very specific item that we can work with, and then maybe eventually update as well. Let's take a look. Using SQLModel, we will do a get or 404 error for any given event. Now, what we're going to do here is very similar to what we've done before. First off, I'm going to use the response model again, and this time it is just going to be the event model like that. And then now we want to build out the session query itself. So I'll go ahead and grab the session data, and we'll bring this in as well. Now what we want to do, of course, based off of this model, we want to look it up for this event here. So we need to define the query first, which is going to be our select call, and it's going to be based off of this model here. And then we use something called .where, and we can grab that model, .a field name, and we can set it equal to this event ID that's being passed through. And that's going to be our query now. So then from that query, we get a result, which would be something like the actual data itself, which of course is going to be our session.execute. And then we're going to grab that query. And instead of using .all, we're going to use .first. The value here would then be returned. And that's pretty much it for our detail view. Or is it? It's close. It's not quite the whole story. Jumping into our list data types here, we're going to go ahead and copy this get event down here. And I want to just change it ever so slightly so that our path is going to be updated to be more appropriate for a detail view. So I'll call this detail path, and that's going to take in, something like that, 12, and then we'll use the detail endpoint. And I probably don't need to put that base view in here anymore. Okay, so now we'll go ahead and grab that detail endpoint here for our request, and I'll just go ahead and set this to R, and then we will do our all across the board, and once again, pprint. This time, instead of status R OK, we'll do our status code in here and see what that looks like. Okay, so if we look at our list view, we should still see that there is probably 12 in here, right? So let's go ahead and just change our list view real quick to descending, just to make sure that we have some data in here that is accurate to what we're looking up. Okay, so back in here and list view, there we go. So we got an ID of 12. I'm going to go ahead and run this, and there we go. So we get that data of 12. If I go one higher, I get a 500 error. That is a server error. This should not raise a server error. It should raise a different kind of error. So this is not quite done. And it has, or rather, this is not quite done. And it has to do with this right here. This query returned back a none value. And we can actually see the error in here that we get. The input is simply none, right? Because we're trying to return back the event model, but we're actually returning back none. So really what we need to do is say if not result, then we need to raise something called the HTTP exception. And it's capital HTTP exception. And we want to add in a status code in here of 404, and then some sort of detail saying that this item was not found or event not found, right? And so we need to bring in this HTTP exception from FastAPI. We'll bring this in like that, save it, and now we'll go ahead and try out this same sort of lookup, and we'll do it again. Now we get a 404, the actual error that you should have for a item that's not found in the database in this case. And so the cool thing about this is this same sort of idea. If I made a mistake on this lookup and turned this into, let's say, a string value here and still did the lookup, let's take a look at what happens there. 500 error this time. So let's go ahead and see what that error is, right? So it's looking for the parameter with the ID of 13. So in this case, it's actually not looking up the ID based off of the string value, right? It's not going to do that. It's going to give us another kind of error, which shows us yet another time that, hey, you want to make sure that you're using the correct data types when you do this lookup. Now, the important part about the actual lookup itself, the request that I'm making, this is a string. It's just FastAPI is parsing it into a number. So that's also another nice thing about this. But overall, we now have our get lookup. It's fairly straightforward. The next part is using this same sort of concept to actually update the data, which kind of puts it all together. The delete method I will leave to you. It's actually fairly straightforward, and there is plenty of documentation on how to delete events, which is something I'm not really concerned about at this point. But updating one is a good thing to know because it kind of combines everything we've done so far. Let's take a look. Let's take a look at how we can update the event based off of the payload that's coming through. Keep in mind, the payload is only going to have a certain number of fields. The way we have it is literally the description. That's the only thing we're going to be able to change in this update event, which is nice because it limits the scope as to what you might potentially change. So the idea here is we're going to go ahead and grab the query and all of this stuff just like we did in the get event. I want this to happen before I go to grab the payload data because I don't need it if I don't have the correct ID. Now, of course, we still need the session in here as well. And then, of course, I also want to bring in my event model as the response model to make it a little bit easier as well. So I'll go ahead and copy that and paste in here. There we go. And then I will update the arguments here just a little bit so it's also easier to review as we go forward. Okay, so let's go ahead and get rid of this now. Now I've got my session. I can still look everything up as we saw before. And this is now going to be our object. This is really what it is. I had it as result up here, but it's the same thing. It's still an object, just like when we created that data. So in other words, we still need to do basically this same method here, just like that. And then when it's all said and done, we will go ahead and return back that object. So the key thing here, though, is the data itself. How do we actually update the object based off of this data itself? The way you do that is by saying for key value in data.items. This, of course, is unpacking those things. We can do set attribute, and we can set attribute for that object of that key value pair that's in there. And again, the actual incoming payload is only going to have a certain number of keys. If for some reason you didn't want to support those keys, you could set that here. So say, for instance, if k equals to ID, then you could go ahead and say something like continue, because you're not going to want to change that field. But again, you shouldn't have to do this at all. It's a bit redundant based off of the actual schema itself. But if you were to make a mistake, then yeah, of course, you might want to do it then. Okay, so with this in mind, I should be able to run this and get it going. So the idea here then is just checking this out or testing it out. So if we look into the send data to API, we have the API endpoint for this, which is basically what we've done before. So now we've got the event data. Here's the description that we want to bring in. This time I'm going to go ahead and say inline test, and we'll go ahead and run that. Now we've got inline test in here. If I go back and list out that data, let's go ahead and do that and see what the description is now. And there is that inline test. So we were able to actually update that data as we saw, just like that. Okay, so this process is very straightforward. Of course, if we tried to update data for an item that does not exist, we will get a 404, right? So going back into the send data here, I'm just going to change it to 120. Now we get a, event not found. And of course, if I change this response to status code, we should see a 404 in here coming through. Great. So yeah, the actual API endpoint is now working in terms of updating that data. Again, this one we probably won't use that often, but it's still important to know how to update data in the case of an API, not just with what our project is doing, right? And of course, the challenge I want to leave you with is really just doing the delete method yourself, which is actually pretty straightforward given some of this data in here as well. So at this point, we now have update, we have create, and we also have list. So we're in a really good spot in terms of our API. The last part of this section, what we want to do is adding a new field. In this case, I'm going to be adding a timestamp to our model, to the event itself. Having an ID is nice because it will auto increment, but actually having a timestamp will give us a little bit more insight as to when something actually happens. Now, what we're doing here is we are actually going to delete our previous models and then go ahead and bring things up. In other words, I'm going to come into my Docker Compose, down, and then -v. This will, of course, delete the database, so it's a lot easier to make changes to my database table. So what you would want to do in the long run is use something like an Alembic, which will allow you to do database migrations. It will quite literally allow you to alter your database table. But in our case, we're not going to be doing that because once we have our model all well organized, we should be good to go and not need to change it very often. And if you do, running this down command is not really that big of a deal altogether. Now, before I start this up again, and this is going to be true for any version of this app, I want to build out the actual field that I'm going to do right now. So the idea here is we're going to go ahead and do something like created at, and this is going to be a Datetime object. So we'll go ahead and bring in from Datetime, we're going to import Datetime. Okay, and this is going to be equal to a field here. Now, this field takes a few other arguments. There's something called a default factory. This default factory has to do with SQLAlchemy that will allow me to do something like define get UTC now, and then I can return back the datetime.now, and then we could actually bring in the time zone in here and do time zone dot and UTC. And then I can just go ahead and say that this value should be replaced for the tz info of timezone.utc. Okay, so just making sure that we are getting UTC now. This will be our default factory. So when it's created, it's going to hopefully go off of that function and work correctly. Now, when it comes to the actual database table, there's another thing that we need to add in. This is going to be our SQLAlchemy type, the actual database type itself, which is going to take in from SQLModel, which we need to import SQLModel as well. And oops, that's not what we wanted. So we'll do SQLModel here. And then I'll go ahead and bring in SQLModel dot Datetime. And then this is going to be time zone being true. So when it comes to SQLAlchemy, you need to define things for datetime objects. It's definitely a little bit different than what we have here, but the SQLAlchemy stuff does creep in a little bit with SQLModel when you're doing a little bit more advanced fields. Datetime is one of such field. And then we're also going to go ahead and say nullable being false. Okay. So doing nullable being false is yet another reason to take down the database and then bring it back up. So at this point, we should have this field automatically being created for us when we go forward. Okay, so now I'm going to go ahead and run the Docker Compose up again. And this, of course, should create the database tables for me. And I'll also go ahead and run my local version of the Python app as well, which is attempting to create those database tables as well. So the only real way I can test to make sure that this is working, at least how we have it right now, is to create new data. So we'll go back into this notebook that will allow for it, and hopefully everything's up and running as it was. Looks like I've got a connection aborted, so maybe I need to do a quick save on one of my models just to make sure that that's up and running. Looks like it is now, so let's go ahead and try that one more time. We definitely saw this before, so I'll go ahead and run it again, and it looks like that time it worked. Okay, great. And so now if I go through this process, I can see there is a time zone being created in here. And of course, I could do this as many times as necessary to update future fields if I wanted to, which in my case, I'll just go and go to 5 and notice that created at is in there as well. Now, one of the other things that you might consider using this same idea of created at is updated at. So you could add a whole nother field that's very similar to this, but it won't have a default factory necessarily. You could still leave a default factory, but if you wanted to create an at field or an updated at field in your update command here, you would then go ahead and set it again. So you'd say something like updated at, and this is where you would go ahead and be able to set that field itself for that timestamp when it may have been updated. That's outside the scope of what we wanted to do here, but the point is I wanted to make sure that I have a bunch of different fields in here that make a whole lot of sense in terms of actually storing data, especially when it comes to a date time field like this. We need to see how we can actually store individual objects itself at any given time, and also have a field that is automatically generating inside of our database, which is exactly the point of this whole thing. Let's actually take a look at how we can do that updated field. I'm going to go ahead and come into our event model here. We're going to paste this and change it to updated at, just like that. There shouldn't be a whole lot of changes we would need to that, but of course this also means that I need to go ahead and do Docker Compose down of that actual entire thing so we can bring it down. Now back into our routing, what I want to do is I'm going to bring in the get UTC now method here, so it's using the same functionality as when it's being created, so that it grabs what that value would end up being based off of all that data. So then in our update view, then we come in here and I'm going to go ahead and bring in object.updated at, and then this is going to be the get UTC now, and then that should actually set it and get it ready for when we go and store it. Okay, great. So with this in mind, I'm going to go ahead and run this again. We'll bring it back up. Now, one of the things, the reason that we have it with the same default factory is because when it's initially created, we might as well also set the updated at field at the same time. So they're going to be the same value when they're initially created, but then in the future, they might change if you then update them. And let's just make sure that everything is running. Looks like it's all running. We're good to go. So let's go ahead and give this a shot. So first and foremost, we want to just send some data in, which I will do with that post method right there. And there we go. So we've got an ID of 1 in here. I'm going to change this to an ID of 1 as well. And we should see that updated at and created at are the same time. It might be slightly different because of the microseconds, but overall, the actual seconds are the same, as we can see right here and right here. Great. So now I'm going to go ahead and update it, and we should now see a change. The created at should be the same. The updated at should be slightly different, and it's not really that much different, but it is different. It's different enough to see that that actually ends up working. So that's how you end up going about doing that. Now, of course, you could also have a field that is completely blank. You don't necessarily have to automatically update it in the future, but that's just a simple way to make that change so you can really see those time differences if you wanted to. Now, the other nice thing about this too is then in our list view, what we could do is we can come in here and do updated at and go based off of that value instead of, we could also do created at, of course, but now we can go off of a different value altogether, in which case we can come back in here and we can see the different data items that are coming through in here, which we only have one right now. So let's go ahead and send a couple more. And of course, we'll update the first one again, just to make these things a little bit out of order. And so let's go ahead and try that again. And what we see in here is now the different data is coming through on how it ends up looking. The updated at is the first one because of course that's how we defined it, but I can always flip it if I wanted to based off of the routing itself. So now ascending, so the oldest one being first, we can go ahead and take a look again and let's list that stuff out. And now we've got the oldest one being first, the oldest updated one, not the oldest created one being first, and then the most recent created one being last, or updated one being last again. Okay, so cool. Very straightforward. I think that would have been really easy for you to do off the video, but I just wanted to show you some techniques to do it in case you were curious about it, and most importantly, to show you this ordering stuff as well as to you can use updated and created at. We now know how to store data into a SQL database thanks to SQLModel. It makes it really straightforward to use this structured data that is validated through Pydantic and then actually stored in a very similar way as it's validated, which I think is super nice. And then extracting that data really looks a lot closer to what the actual SQL is under the hood, which I think will actually help you learn SQL as well if you are trying to learn it, because the way this query ends up being designed is it's very much like SQL itself. So SQLModel, I think, is a really, really nice addition to the Python ecosystem. And of course, I'm not alone in that. It's a very popular tool. But the idea here is we have the foundation to read and write data into our database. Now we need to elevate it so we can read and write a lot more data and do so by leveraging time series. When it comes to analytics and events specifically, we definitely want to turn it into time series data. Now, the difference between it are going to be mostly minor based off of all of the tooling that's out there. So actually turning this into time series data is very straightforward. So let's go ahead and jump into a section dedicated directly to that. We're building an analytics API so that we can see how any of our web applications are performing over time. In other words, our other web applications will be able to send data to this analytics API, so we'll be able to analyze it and see how it's doing over time. The key word is over time there. Now, a big part of the reason that our event model didn't have any time fields until later was really to highlight the fact that Postgres is not optimized for time series data. So we need to change. We need to do something different. And of course, that change is going to be Timescale and specifically the Hypertables that Timescale provides. Now, we have been using a Timescale database this whole time, but we've been only using the Postgres portion of it. So now we're going to convert it into a Hypertable because that revolves around time and time series data. It's optimized for it. Now, a big part of that optimization is also removing old data that's just not relevant anymore. Now, it removes it automatically, and of course, you can build out tooling to ensure that you're grabbing that data if you wanted to keep it in some sort of cold storage long term. But the point of this is that we want to optimize our analytics API around time series data so we can ingest a lot of data, and then we'll be able to query it in a way that we're hopefully kind of familiar with at this point by using Postgres. So at this time, we are now going to be implementing Timescale and specifically a package I created called Timescale Python. We'll look at this in just a moment, but as you can see here, this is exactly like our SQL model with a few extra items, a few extra steps to really optimize it for TimescaleDB. Now, these extra steps are not really that big of a deal, as you'll come to see. And a big part of the reason they're not a big deal is because the Timescale extension is the one that's doing the heavy lifting. This is just some configuration to make sure that it's working. Let's go ahead and get it started right now. We're now going to convert our event model, which is based in SQLModel, into a Hypertable, or at least start that process so we can start leveraging some of the things that Timescale does super well. So the way we're going to do this is we are going to go ahead and bring in from TimescaleDB, we're going to import the Timescale model, and then we're going to swap out SQLModel for that Timescale model. At this point, it is still mostly the same. So if we actually look at the definition of the Timescale model by hitting Control-click or right-click, you can see the definition of this model. It is still a SQL model. It is based off of that. And then we've got ID and time in here. So two default fields that are coming through, and then some configuration for Timescale specifically. But let's take a look at these two fields. We've got an ID field. Hey, that looks really, really familiar to what we were just doing with our ID field. It has another argument in here that is related to SQLAlchemy on SQLModel. If you ever see SA like that, that is referring to SQLAlchemy, which is another part or dependency of SQLModel. It's an older version of SQLModel if you want to think of it that way. Now, the other thing here is we've got a datetime field, which, hey, what do you know? We've got a default factory of get UTC now. It is a datetime object with a time zone, and it's a primary key as well. So we actually have two primary keys. So the Hypertables, which is what we're building, is going to rely on a time field, absolutely, which is part of the reason we declare the time field altogether. The other thing is we have a composite primary key, which actually uses both of these fields as the primary key. So the idea here then is we want to actually use this time field instead of the one we have. So if we look back in our event model, we had this created at field in here, which we can now get rid of, as well as this ID field. Now, the other thing you'll notice is we've got this get UTC now. It's in both places. And so we can actually use the TimescaleDB version of get UTC now instead of having our own. Now, of course, you could still have your own, but it's not necessary at this point since we have this third-party package that we are now relying on. We can use other fields to rely on it as well. So the last real thing about this model is deciding what is it that we're actually tracking here. Now, in my case, what I'm trying to track, or the time series data that I'm looking for, is page visits. So how would we think about page visits? Well, that's going to count up the number of visits at any given time, right? That's the thing. That's what we're counting up. This is a little bit different than like sensor data, for example. So if this was sensor data, you would have a sensor ID instead of a page, which would be an integer, and then you would have a value, which might be a float, right? And so you're going to then do something like the value, or maybe let's say the average value of a sensor at any given time, right? So that would combine those two fields. But in our case, we want page visits. We want to count up the number of rows that have a specific page on it. So the reason I'm bringing this up is mostly so that when we think about designing this model, we want to rethink what fields are required. In the case of page, that one is absolutely required. We definitely need page, otherwise it's not an event. So we're going to go ahead and say that it is a string, and this time we're going to go ahead and give it a field with an index being true. Now, making an index makes it a little bit more efficient to query, but the idea here, of course, is going to be it's going to be our about page or our contact page or so on. And of course, inside of Timescale or Postgres in general, we can aggregate this data. We'll be able to count the pages. We'll be able to do all sorts of queries like that, which we'll see very soon. But the rest of the actual event model, we could either get rid of or we can still use. The updated at, I'm probably never going to update this data, but it is nice to have that in there, and then a description in there as well. So we're really close to having this as a full-on Hypertable. It's not quite done yet, and we still have to modify a couple things. Those are related to how we are using our session. So we're going to change our default engine in here, and then we need to run one more command related to initializing all of the Hypertables. It's time to create Hypertables. Now, if we did nothing else at this point and still use this timescale model, it would not actually be optimized for time series data. We need to do one more step to make that happen. A hypertable is a Postgres table that's optimized for that time series data with the chunking and also the automatic retention policy where it'll delete things later. This is a little bit different than a standard Postgres model. But again, if we don't actually change anything, it will just be a standard Postgres model. Now we want to actually change things. We want to commit those changes. Now, the way we're going to do this is inside of session.py. We're going to go ahead and import the TimescaleDB package in here. And underneath initDB, I'm going to go ahead and print this out and say creating something like Hypertables, just like that. And it's as simple as doing timescaledb.metadata.createAll engine. This function here is going to look for all of these timescale model classes, and it will go ahead and create the hypertables from them if they don't already exist. It's really just a conversion process. It's still a Postgres model under the hood, and then it actually turns into a hypertable. Now, there are issues that could come up with migrating your tables, so I'm not really going to talk about that right now. It's kind of outside the scope of this series if you're going to be changing your tables very often. But the point is that this right here automatically creates hypertables. The TimescaleDB package has a way to manually create them as well, especially when it comes to doing migrations and making those changes that are a little bit more advanced. Now, the big reason that I'm talking about that at all is because we want to make sure our model is really good, ready, set, because we probably don't want to be changing our timescale model very often, or really our hypertable very often. Unlike your standard Postgres table, you might change that more often than something like a hypertable. Now, the idea here then is after we've got our creating hypertables, we have one more step that we need to do, and that's changing our create engine because we actually want a time zone in here as well. So there is an argument that you can pass in time zone, whichever time zone you are using. In our case, we've been using the UTC time zone, which of course we see in our model itself, where it's get UTC now. That's going to be the default time zone we use, and it's the default one for the timescale model anyway. Now, I recommend just sticking with that time zone because you can always change a time zone later. Using UTC makes it really easy to remember, hey, my entire project's in UTC. We can convert it if we need to. Okay, so the idea also with this time zone is we might want to put it into our config.py here, in which case I would go ahead and do something like db time zone and then just paste that in here and then have the default being UTC once again, in which case I would then import it into my session.py and do something like that. Great. So we're not quite ready to run this command. And when I say run this command, I mean that we need to take down our old database and then bring it back up so we can make sure that everything's working correctly, including any changes that I made to this model. But there are a few other things that we need to discuss before we finalize this model, and that has to do with some of the configuration that we want to use inside of our hypertable itself. There's a couple configuration items we want to think about before we finalize our hypertables. So let's take a look at the timescale model itself. And if you scroll down, there's going to be configuration items in here. Maybe some aren't even showing yet. The main three that I want to look at are these three. First is the time column. This is defaulting to the time field itself, right? So we probably don't ever want to change the time column itself, although it is there, it is supported if you need to for some reason. In Timescale in general, what you'll often see, the time column that's being used is going to be named time, or the datetime object itself. So that one's I'm not going to change. The ones that we're going to look at are the chunk time interval and then drop after. So let's go ahead and copy these two items and bring them into our event model. And I want to just go ahead and set these as a default of empty string here. So what happens with a hypertable is it needs to efficiently store a lot of data, which means that it's going to store it in a chunk. Each chunk is like its own table itself. Now, you're not going to have to worry about those things. Timescale will worry about them for us. The things we need to worry about are the interval we are going to create chunks for, and then how long we want to store those chunks for in this drop after. So this is actually very well illustrated inside of the Timescale docs by taking a look at a normal table and then taking a look at a hypertable. A hypertable is a table, and then it has chunks within that. So as we see here, we've got chunk 1, 2, and 3, and then each chunk corresponds to the interval that we set. So for example, this chunk is for January 2nd. This chunk is for January 3rd, and so on. Because the time interval is for 1 day, the entire chunk is a day at a time. That's kind of the point here. Hopefully that makes a little bit of sense. But the point of this also with respect to chunks is if you have a lot of data, how you handle your chunks is going to be different if you have a little data, right? If there's very little data, your chunks could probably be a lot longer because you're not taking up that much room in any given chunk. And also you're probably not going to be analyzing that data much for any given chunk. So for example, if this is your very first website, your chunk time interval might be 30 days. And it actually is going to be listed out as interval 30 days like that. And so that's how you write it. You could say something like 30 days. Now, one of the downsides of having an interval of 30 days or too long of an interval is you will have to wait after that interval passes to make a change. So say, for instance, right now we say, hey, it's going to be interval of 30 days. That means all of the data coming in right now has a chunk time of 30 days. If in a day or a week, I want to change it down to 1 day, then we have to wait that full 30 days before this new interval would end up changing. Now, these automatic changes right now are not currently supported by TimescaleDB's Python package, or the one that I created at least. Maybe at some point it will be, but the point of this is we want to decide this early on. I actually think interval of 1 day is pretty good for what we're going to end up doing. If we end up having a lot of data, then you might want to change this interval to like 12 hours. But more than likely, I would imagine 1 day is going to be plenty for us. So the next question becomes, when do we want to drop this data? Now, Timescale will automatically drop this data based off of what we put in this drop after. So in the case of our interval here, we could absolutely say drop after 3 days, but that actually doesn't give us much for time for analyzing our data. And what do I mean by drop after? I mean quite literally, after 3 days, this thing would be deleted. This would be completely removed from our table. It's not going to be there anymore. This helps make things more optimized and also improve our performance altogether, while also removing like storage that we just don't need anymore. We might not need that anymore. So we could always take that old data and put it into something like cold storage, like S3 storage. But what we want to think about here, though, is when realistically would we want to drop some of this old data? Again, it's going to be a function of how much data we're actually storing. So this interval can also change as well. So for example, if I did 2 months, then I would only have at most the trailing 2 months data. If I wanted to have a little bit longer than that, like 6 months, then again, I would only have at most 6 months of data, at least in terms of querying this specific timescale model. Again, we can always take out those chunks and store them later if we wanted to. In my case, I'm going to go ahead and just leave it in as 3 months. I think that's more than enough. You might also change it to 1 month and so on. And you could change these things later, but I wanted to make sure that they're there right now so that we have them and we understand kind of what's going on with our hypertables, or hopefully a lot more as to what's going on with our hypertables. So the way we're going to be chunking our data is going to be with 1 day, and we're going to keep the trailing 1 day for 3 months. So we'll have at least that much data going forward. Let's go ahead and verify that our hypertables are being created. First and foremost, I'm going to go into session.py here, and I'm going to go ahead and comment out the process of creating those hypertables because we're going to do it in just a moment. Then I'm going to go ahead and run Docker compose down just like that. And then we're going to go ahead and bring it back up so that we can quite literally have this working once again. Okay, so we should see creating database regardless of how you end up doing it. But the idea here is we now have our database up and running. So to verify this, what we're going to be using is something called PopSQL, or PopSQL.com, and just sign up for an account. It's free, especially what we're doing. And then you're going to want to download it, which is going to be available on this desktop version right here. And you can go ahead and download it for your machine. Once you do, you're going to open it up and you're going to log in. You're going to probably see something like this. So the idea here is you're going to select your user and click on connections. And then you're going to create a new connection. So we've got a lot of different connection types in here that we can use to really just run different queries that we might want to. In our case right now, we're just going to go ahead and verify that our database is a Hypertable database or has a Hypertable in it. So that means that we're going to be using Timescale here. Now, the idea here is we could also use Postgres. Both of them are basically the same, right? The connection type is basically the same. It's just a little bit different. So we want to use Timescale to verify that it is a Hypertable when we look at it. And then the next part is going to be our connection type. We're going to go ahead and use directly from our computer. We want to make sure we do that. And of course, this is going to be on localhost. And the port here is 5432, the standard Postgres port. And it's also the same port we defined in compose.yaml, this port right here, the first one of the two. Great. So now we've got that. We now need to fill out the rest of it, the database name, which of course is our TimescaleDB, the username, which is going to be our Timescale user, and then also the password timepw. And that's it. Then I'm going to go ahead and save that, and we can run connect. And now what we should be able to do is grab this data. So I'm going to refresh here, and we can see there's our event model, and I should be able to go to the event model itself, and we can see that it's not a Hypertable, at least not yet. So back into our session here, I'm going to go ahead and change it to see if it will create those Hypertables from here. So as soon as I save this, I should see it says creating Hypertables, and hopefully I don't see any other errors. This is true regardless of what version we're using here. But ideally speaking, we have all of our Hypertables. So if I refresh in here, this might actually show me my Hypertables. It might not. So the reason that it might not be showing our Hypertables is maybe we need to just start over a little bit, in which case I'm going to go ahead and go Docker Compose down again, and then I'm going to go ahead and do Docker Compose up just to see if that ends up solving it. It might be a caching thing as well, so we would also look at that. But there we go, creating Hypertables and all that. Let's go ahead and refresh in here. Right now it's still saying no, which it shouldn't. So let's go ahead and close out PopSQL for a moment and see if we can just reopen this up. Again, I think it's a caching thing, which is not that big of a deal at all. We just need to refresh PopSQL itself so that we'll be able to run with our previous connection. Now, there's a chance that we might need to re-enter our credentials. I don't think that's going to happen, but here we go. And now it shows, sure enough, it shows a Hypertable right away. And notice that compression is disabled currently, but it does show us the number of chunks we have. So what if we actually start making some data? The way we're going to do this is by jumping into our notebook here. I went ahead and had this one single event, right? So we had this post event that we did before. Off the video, I went ahead and did this event count where it sort of randomizes stuff, but it creates 10,000 events for us. So I'm going to go ahead and run that. And what we should see in our table, at some point, it will just be one chunk. So it's going to take a moment maybe for that to be flushed out completely, or maybe we need to do a query altogether. I'm not actually sure in terms of why that's not showing up just yet, but it is bringing in all sorts of data for us, which is pretty cool. So we will test this out a little bit more. The key of this was just to verify that it does say Hypertable. Notice that compression is disabled. That goes back into our timescale model where the default for compression is false. So you can absolutely add in compression to make the data even more optimized for storage. But for now, we're just going to leave it as is, and then we'll go through the process of actually seeing all of this data. We will use PopSQL a little bit more to run some SQL queries, or really to verify them, but we're not going to run that many SQL queries. Instead, we will do the related queries right inside of our notebooks using SQLModel as well as TimescaleDB, the Python packages. Now, what would be best is if we actually ran this a number of times over a number of days to simulate the actual process of visits. But of course, I can still run this a lot, and we get 10,000 visits per time or 10,000 events per time, and we'd actually be able to see a lot of data coming through in here at any given moment, right? So 10,000 events, and of course this is happening synchronously, so it's not quite like what a real web application would be like, but it is still at least giving us a bunch of data that we'll be able to play around with. Let's take a look at how we can do some of the querying with the SQL model. Now that we have a Hypertable and we are able to successfully send data to it, I want to actually be able to query this table, and I want to do so in a way that is still leveraging the event model itself before I create the API endpoints. Now, we have already seen how we can query it in FastAPI, but I want to actually design the queries outside of FastAPI before I make it an API endpoint itself, just to make sure I'm doing it correctly. Now, the way we're going to do this is inside of a Jupyter notebook. So we'll go ahead and do MBS. I'll go ahead and do 5, and we'll go ahead and do SQLModel queries.ipython notebook. And then in here, I'm going to go ahead and import a few things. The first thing is going to be sys. The next thing is going to be from pathlib. We're going to go ahead and import our path here. So when it comes to being able to import something from a model like models.py, there's no real clean way to do this. I can't just go from source.api.events.models import event model, right? This will most likely not work because there's no module named src. Now, this is in part because we're inside of the MBS folder here. And so there's a number of different ways on how we would be able to import this or grab it. But the way I'm going to do it is I'm going to say my src path equals to path of ... /src. And then we'll just go ahead and resolve that, right? And so if we resolve that and take a look at what it is, that is that src folder right there. And so what I want to do is I want to append this to my system path. So all I can do is sys.path.append will take that string of that src path here, just like that. Okay, so that will append it to our system path, which means then I can actually just go ahead and do, instead of src, I can just use api.events.models, and I should now be able to grab that event model and have no errors related to it. And I mean, I could also just go through and manually add all of this stuff in as well into the notebook itself. But having this event model allows for me to do a few other things as well. Like I can go ahead and do from api.db.session, we can import the engine as well, which of course is going to give us this engine right here, which has the database URL already on it, or at least in theory it does. So it's another part of that as well. Let's go ahead and run that one. Sure enough, it ends up working. So next up, what I want to do is I'm just going to do a very basic lookup, a very basic query for this first part, and then we'll come back and start doing more and more advanced queries. So what we want to do here, I'm going to actually put all of the imports in the same sort of area. We'll go ahead and bring in from SQLModel. We're going to bring in the session itself and then run that cell. And then to use this session, we'll do with session, and then we'll pass in the engine in here. And then we'll go ahead and say as session, and then I'll be able to do my different session things that we might want to. This, of course, is going to be basically the same as what we're doing in our route. It just FastAPI handles it for us with that session stuff and all that. But we can actually do this same exact query in there. So let's go ahead and grab that and just verify this in here with our session. And I should be able to print out the results in here as well. We also need to import the select. So let's go ahead and do that as well. And now we'll run this and we should get the same sort of data coming back. Okay, so that gives us a result. But what I really want to see right now is before we build out the rest of the queries, I want to actually see the raw SQL query here. Now what we do is we bring in compiled query equals to query.compile, and then we want to go ahead and bring in something called compile keyword args here, which I'll just go ahead and copy and paste. But the idea is compile keyword args, the literal binds being true. I'll show you why right now. So if we print out the compiled query, and then if we print out the string of the actual query, we see a couple different things. So I'm going to go ahead and print this one little line to separate it a little bit. So the compiled query is this one right here. The other query has a parameter in here that does not have the literal binds in here at all. So the nice thing about this is we would be able to change the limit with that parameter. This is not something we're going to do right now. The point is I want to be able to use this compiled query by going into PopSQL. I can open up a new tab in here and I can paste that query in and just run that. And so what it'll do is it'll run everything that we have in here with all of that data. So we've got the pricing data and all the pages and all that. So notice that the pricing data, it looks like when we put it in, it didn't have a initial slash in there, which is kind of interesting. But overall, the data is in there, and there's a lot of data going on. And this is how we'll be able to verify that our queries are good. And so we can continue to refine what kind of queries we'll end up doing inside of our database. Now, when you're working with database technology, it's a really good idea to do some of these queries just to verify that it's working before you were to actually put it somewhere else. So now that we've got that, I want to jump over into doing time buckets. We're now going to take a look at time buckets. Time buckets allow us to aggregate data over a time interval. So it's actually a really nice way to select certain data that falls into an interval. In our case, we're going to end up counting the correct data for the correct pages, but we want to start with just the basics of the actual time bucket itself. So one of the things I want to do is grab this session here because we will be using the session itself, and we're going to be working based off of roughly this. And so the nice thing about these queries here is we can put it into a parentheses. And of course, this is just Python related, but then we can separate them out line by line. Now, I don't really care about the limit right now, so I'm going to go ahead and get rid of that. And I'm not actually going to run this query. We are going to chunk it down a little bit by using the time buckets. So to do this, we're going to go ahead and do from TimescaleDB.hyperfunctions. We're going to go and import the time bucket idea here. And then we're going to go ahead and add in bucket equals to time bucket. And then we'll add in some amount of time. I'll leave it in as 1 single day. Now, we want to do it on a specific field that we're going to end up using, which in our case is that event model.time. Now, this is where keeping the actual field, the time field, consistent makes it a little bit easier. So if I need to change to a different model, .time is still that .time. So that's kind of the idea here. So we can actually select it based off of that bucket itself. We can come in here and just select that bucket. We can also add in our page in there as well. So if I do event model and then .page, I can bring that one as well. That, of course, is an arbitrary field at this point. But now what we can do is actually see this. So I will leave that compiled query because I might look at it in a little bit. But for now, I'll go ahead and do results equals to session and then .execute of the original query. And then we'll go ahead and do fetch all to see what that looks like. And I'll use prettyprint to actually do this. So let's go ahead and import prettyprint. So from prettyprint or pprint, import pprint. Okay, so I run that and now I can see all of this data coming through based off of time and all that. So there's a lot of data. I'm actually not sure how much data is in there. It's not quite what I want though, right? So I want to change this a little bit. And of course, we don't order it by updated at. That's not even being selected. We've got our time bucket and then our page. Those are the only things that are being selected. And if we scroll down, we will see that there is all instances of that. So like it's going to have duplicates in here, but it actually removed the original time to just being based off of the date, right? It's not quite the same as what you would see up here, which of course we could verify by running the results up there as well. So if I came up here and ran those results, I should be able to see that there are differences in the time itself. So the date time object in here is certainly different than this. So it's already showing the aggregations at work is kind of the point. I'm going to go ahead and move these import statements up a little bit. But now that we've got that out of the way, we've got a way to aggregate this data based off of buckets. We want to do one more thing, and that is I want to actually count the number of items in that time bucket or based off of that time bucket. So the way we do that is we bring in from SQLAlchemy, we're going to bring in a function in here. And so this function right next to the page is just going to be function.count. And that's it. We can give it a label as well if we wanted to. We can say something like event count in here, and then we could reuse that label later, but I'm just going to leave it as simple as possible by using function count. If I go ahead and run this, we get this other issue now. So this is now not necessarily giving us all of the right data. So I'm going to go ahead and get rid of this order by here altogether. We'll just use the select for now, still not giving us exactly what we want. Now this is happening in part because we need to group the data somehow. So how is this count going to work? What is it actually counting? So the way we do that then is we come in here and do group by. And the way we want to group this is with the time and the page. So those two things together will give us the grouping that we're trying to count. So I can go ahead and run this again. Now it's showing me the grouping that we're trying to count. This is now looking pretty good, I think. So it's giving us all of this data in here. And what if we change this to 1 hour? We should be able to see something very similar to that. Maybe we didn't change very much in an hour. Let's change it to 1 minute. now we can see those chunkings coming through because of all that data that's been coming through. So if I were to run and send more data in, it's been more than a minute, I should be able to see a bunch of data coming through with these chunks as well. We could always take this a little bit further as well, but overall what we've got is now a time bucket chunking. And we probably also want to maybe order it. So we'll do order by, and in this case, I'll go ahead and say bucket, and then we will maybe also do the page itself. So the page model is being ordered, and then, or maybe not even in that ordering, we can play around with these things a little bit. Oh, we forgot a comma. Let's run that again. There we go. And so now it's in order, right? And we see. And of course, it will skip minutes, right? So if there's no data in there, it's not going to have any chunks. So it's going to be skipping things, which is what we're seeing here. Now, there is a way to do something called a gap fill, which is definitely a function that the TimescaleDB package has. So instead of using time bucket, there's time bucket gap fill, which allows you to fill in empty spots that are missing, that might be missing, by aggregating the data. In my case, I don't actually want any empty data coming in here. I'm just going to leave it as is because these are the actual data points and the actual counts. I'm not going to guess what the counts might end up being. Now, of course, the actual analytics for a page would be a little bit different than this if we were actually grabbing web traffic, right? It's not going to be consistently skipping minutes based off of the ingested data for all of the data. It'll just be for some of it. Okay, so another thing about this is we can then narrow this down to the pages we want in here. So for example, if we go back into when we created this data, I'm going to scroll up here. I've got a few pages in here. So I can go ahead and grab that, and we can grab those pages and put them right in here as to like narrowing down the results that I want to have. And the way we do that then is by adding a where clause in here. So we'll do dot where. And inside of here, we can then say that this page and then dot in with an underscore, one of these pages. All right. So if we run that now, it's going to go based off of those pages. And so if I were to do, let's just say the about page here, those are what's happening on that about page over that time bucket. So if we do 1 day, not going to be that big of a deal right now. But of course, over time, hopefully we'll see those days come through and it will end up working based off of this data. So it's aggregating, I think, really well. And it's doing so with all the chunks that are available and all that. So it's really, really nice. And we have the ability to do all sorts of advanced querying in here. The other part about this is our where clause. We could do it based off of datetime as well. So if we were to bring in additional imports, like from datetime, we can import datetime and time delta and then time zone, right? And so what we can say something like this, where we say start equals to datetime.now.timezone.utc, and then we can subtract time delta, and we can do something like hours equals to 1, and then we could do finish or end being basically the same thing. And then we can just go ahead and add in another time delta in here, which would allow you to come in and say that the time, so event model.time is greater than start, comma, and then event model.time is less than or equal to finish. Now that actually filters it down a little bit more, but the time bucket is already doing some of that for us. So if we were to go into the day, and let's say, for instance, it's doing a time bucket of the day, but we actually narrow it down a little bit, it's probably going to give us different results. So let's see here. We've got day, the about page is 7,500, but that's happening within the last hour for today, basically. If I were to get rid of those and run it again, it's quite a bit more, right? So it is the ability for us to filter it down if we wanted to. This, I think, is maybe potentially redundant to doing the time bucket because the time bucket already does that really effectively, but you will see this from time to time, especially when you go into the time bucket gap fill, then you might want to fill in the gaps of a specific interval of time. Now, the thing about this bucket here is you could still do a lot of this stuff in standard Postgres itself. So these SQL queries can get a lot more complex, of course. And then what we have here, it just so happens that, Hypertable, and more specifically Timescale, has some of these functions built into it that allow for it to happen efficiently. So this kind of aggregation is very efficient. And then we can take that compiled query. Let's go ahead and get rid of the printed results here. Let's take that compiled query from the bottom, which would be pretty big. So I'm going to go ahead and actually start from the top and hopefully grab that whole thing, and we will bring it into PopSQL here, and we'll go ahead and run that new query, which let's make sure that it does finish with page at the end there. It looks like it does. Then we'll go ahead and run this, and now it does basically that exact same query, but we can just test it right inside of SQL itself, which is exactly why we have that compiled query there in the first place. But of course, you might not actually run through the SQL stuff very often. You might just be running it with Python, but the underlying SQL is definitely still there, and it works essentially the same way as SQLModel does here. So that's pretty cool. It's a very straightforward way to do these aggregations and be able to start analyzing our data. So all we really need to do is turn this into an API route that will allow for us to do basically this stuff. So let's take a look at how we do that now. It's time to bring in that time bucket querying and aggregating into FastAPI. The way I'm going to do this is I'm going to actually remove our old list view, our old events list view, to being specifically just aggregations. Now, when we start getting a lot of data, it's really unlikely that I'll use the list view very often, if at all, to see individual items. I could always bring it back later if I wanted to, but realistically, I want to see aggregations here. This is going to be that lookup. So the way this is going to work is by going into our model here, we can grab all of the things related to the query. I don't need the compiled query, and I will use results in here in just a little bit. But the idea is bringing in this query and getting rid of what we had before. So I'll go ahead and paste this in. This, of course, means that I'll need to import several things, which, of course, I already have some of the imports on here. So I'll go ahead and bring those in as well. And then we need the TimescaleDB import as well. So let's go ahead and do that too. Okay, great. So that should give us our new query in here. And then the result here, I'm going to go ahead and do fetch all. And that is actually what I want to return now, is just simply those results. So that, of course, means that I need to update my response model. So I'm going to leave some of the default arguments in here to start, but I do want to change the response model. Now, the response model itself is going to be very much based off of what we already saw in here. So if we were to run this again, we can see that it's a datetime object, the page, and then some sort of count in here. So that's what I want to have as well. But I want to be a little bit more specific about that before I create the event list schema or the response model together. So that means inside of select, I want to add a label to each one of these. This label, we can go ahead and call it bucket. This one is going to be just simply going to be page. And then this one right here is going to be labeled as count. What do you know? Basically the same thing as what they are, but just adding this label on here, which is a characteristic of SQLModel, will make it really easy to then have a response model of some kind. Now let's remember what's happening here. This query is going to be searching more than one. It's always going to return back a list, which means that I also want to bring in from typing, we're going to import list here, and we're going to go ahead and use a list of some kind. So back into models.py, let's go ahead and actually create our new schema, which is going to be loosely based off of this event schema. Not quite the same, but count will be the same. Then we want to have page in here, which is a string itself. And then we're going to have a bucket in here, which is a datetime object, right? And so we already have that imported in here because of updated. But the idea is this is now going to be our event. We can call this our event bucket schema, something like that. And then we'll go ahead and bring this back into our route. We'll use that as our import now, and that's what we're going to list back. That's what's going to be our new response to this request. So not a huge difference. Now, one of the things we could think about too is maybe we change this query to being in its own model or its own field here, like maybe something like services.py. That's not something I'm going to do right now because I really just want to work on what we got here. Now, the other things I'm going to get rid of are this start and finish. I don't necessarily need that. I'm just going to go based off of the bucket itself. You totally could do the start and finish in there, but using just the bucket will allow for me to do these as query parameters, which we'll do very soon. But now that we've got this API endpoint, let's just make sure that our server is running. So we'll go up here And it looks like we need to maybe save models.py. And there's our, oh, we got a little error there. Let me just resave that. There we go. So it looks like everything's running both in Python as well as Docker. Great. So now I'm going to go ahead and make an API call, which of course we already have that endpoint in there with list data types. I can go ahead and run each one of these. I might need to restart the server here or restart the notebook itself. But there's my results right there, right? And of course, these are off of 1 day. So I want to be able to change this. I want to be able to come into my request and do params and say something like duration, and we'll go ahead and change that to 1 minute, right? I want that to be a URL parameter that I can change. And maybe in here, I also want to go ahead and say pages and add in something like /about, and let's see, another one, maybe contact, right? And so there we go. Great. So those are the parameters I want to bring in. Now, we can do this fairly straightforwardly inside of FastAPI, which uses a query parameter. So the query parameter we can bring in as page, and this is going to be an str, or rather, not page, but we called it duration. And this is going to be a string of some kind, which basically will be a default of 1 day. Okay, so that query we need to bring in from FastAPI. We'll go ahead and import query in here. And so having a default in there is nice because then I can use that as my parameter here. Let's make sure we put a comma. Great. Okay, so the next one is going to be our pages. This is going to be a list, but the query itself, we'll go ahead and have a default of none, or maybe just a default of an empty list. Let's just try with none for now, and we'll leave it as is. Okay, so this is going to be our default pages. Now, the pages itself, I'm going to go ahead and call these lookup pages, and I'll have some defaults already in here. We could always say something along the lines of our default lookup pages and set that up here so we can kind of readjust that as we see fit. But we'll have some default lookup pages in here that will basically be this right here. And we'll go ahead and use those inside of our query here for that lookup. Great. So the idea then is inside of here is if there are pages coming with the query, we would say pages basically, and we would then want to check if is instance of a list and pages is greater, or the length of pages is greater than 0. Else we will go ahead and use this. So a nice one-liner for the condition. Basically, if all of these conditions are met, it's going to use those pages. Otherwise, it's going to use the default ones. And then that's now our lookup and now our API endpoint with that time bucket and all of those aggregations. Let's just verify that this is working by going back into our notebook. And there we go. So we've got it at 1 minute. Here's that 1 minute. We could also verify this by taking a look at the time that is happening. Obviously, if you had a lot more data, it'd be even more clear. Then we can also say something like 1 week. Right? So we can change it as we see fit, and it shows only those items in here. If I were to use an empty list here, it's going to then go ahead and use all of them that I have available in my default ones. Now, in my default ones, I'm actually missing one, which is when I was playing around myself, I didn't actually put a leading slash on pricing as well. So I did it in 2 ways. So when you actually end up doing this, you might want to have some default pages that are in there. But overall, once I actually add that other one in, we can see that that one has a lot of data as well. Now, this distribution is probably unlikely. I doubt about page would be far greater than anything else. But the idea here, or even the contact page being that high, right? So the analytics here is the data points are actually only because when we created it, it just did some pseudo-random creations. The actual data, once you put this into action, would look quite a bit different. Okay, so pretty cool. Now we've got an actual API endpoint to get the aggregations from our analytics. We have a way to create the data. We have a way to aggregate the data. Both things are what's critical here and what we will be using once we actually put this thing into a deployed production environment. We now want to augment our event model so it's a little bit closer to extracting real web data. So like, for example, you want to know what web browser people are using to access these pages, or you want to know how long they spent on those pages. Now that is more realistic web analytic data. Now the point of this is to show you how you can add additional fields and what you would need to do to be able to use the time bucket equation to make sure that you can also include those fields and see how those might play out. So the idea here then is inside of our event model, we're going to change it. Now, before I make any changes here, I'm going to go ahead and run the docker compose down-v to make sure that all of the data has been removed. Now, the reason for this is because I don't have database migrations in place to make these changes. You could have database migrations in place. I don't. So we're going to go ahead and remove some of the fields that are in here by default. I'm going to go ahead and get rid of the comments even for them because we no longer need those, but I want to add in additional fields. The ones I'm going to add in are these right here. We've got our user agent, otherwise known as like the browser, the web browser that's being used, their IP address to identify their machine itself, the refer, like, if it's coming from Google or from its own website, the session ID, which you might have in there as well, and then how long they spend. Now, of course, you could always have more data than just this as well. So what we're not going to do, though, is change this data. We're just going to ingest this raw data, and we will be able to change it later. That's more specific to the user agent so that you can see the specific operating system that's being used, as we'll see in just a moment. So now that we've got this event model, I also want to get rid of some of the schemas that are going to be a little bit different, or at least change them. So the create schema is no longer going to have this description in here. It's just going to have these things. The update schema, I'm not going to allow updates any longer. So I'll go back into my routing and I will get rid of all of the things related to updating any of these events. Seeing how to update things was important, but now we no longer need them. So I'll go ahead and get rid of that as well. And of course, you could always review the old commits to see all of that old data if for some reason you wanted to go back and see it. So at this time, we don't actually have that much different in terms of our data itself. So let's go ahead and bring back Docker. I'm going to go ahead and do Docker compose up watch. And then I want to make sure that my models, everything's saved. And I should see something along the lines of we've got a database in here. Great. So these actual fields themselves, maybe you want to change them in the future. Maybe these aren't actually the ones you'll end up using. That's not really the point here. The point here is how do we add fields to the data we want to collect? And then how do we look at that in terms of our events themselves? So this actually means that we need to modify the data we're going to send. So inside of our data here, I'm going to go ahead and do a pip install faker. Faker is a Python package that allows for us to have some fake data. And I'm going to go ahead and grab some of the data that I have, which is going to be just this import here. I have additional pages in here now. I have 10,000 events that I want to bring in. Faker can allow for, fake session IDs in here. We can have however many that we want. In this case, I'm just going to use 20, but if you want to use 200, feel free to do it. We still have the same API endpoints. I added a few refers in here, and so we can actually start the process of building out this data. So what we are going to do here is very similar to what we have up here, where we're going through a range of events, and we're going to get a random page, which we have right there. Then we're also going to go ahead and get a random user agent, which we can use Faker for. So Faker has all of these user agents in here that you can go off of, right? So just make sure that you have all of that fake stuff implemented. Then we're going to go ahead and just create a payload based off of this data. So the payload is going to be, simply these key value pairs in here. It's really just a dictionary, but I liked looking at it this way just to make sure that it's all working great. Okay, so we've got a duration. Maybe we do 1 to 300. There's a lot of things that we could do in that realm. But the point here is we now have a new payload that I can send back into my database or into my actual API service with all of that data. So I'm gonna go ahead and run it, and there it goes. So we can see all of the different data items that are coming through in here. We see the user agent and all of that. Okay, so while that's running, I'm gonna jump into my queries from the SQL model. Now, actually what I want to see is the list data. I'm going to go into the API requests themselves, and we'll just go ahead and run this. Within that API request, there we go. We actually see the same sort of data coming back. So if I say something like 5 minutes, we should see a lot of that same data coming back as well. Now the pages are going to be a little bit different because of my original routing, how I had it set up. So let's go ahead and grab these new pages in here as our new default pages. So go ahead and copy this, and then we'll go jump into our routing, and our new defaults are going to be those right there. Great. Now, of course, you don't necessarily have to even narrow down the defaults. You could remove that altogether, which would allow for all of the pages to show up. Okay, so with that in mind, now that we've got that there, we're going to go ahead and run this once again in that list data types. Let's go ahead and run it. And there we go. So now we have a bunch of different pages in here, and we can see the contact and all that stuff. Okay, so now what we want to do is we want to see this a little bit different. So going back into the routing, we want to add a new field in here, and we want to count the number of instances for that field. In other words, most of this is basically the same. So let's go ahead and do that with, let's say, for instance, our user agent. So if we came in here and we did event.userAgent, and then we added a label as something like UA, like user agent, we could do something along these lines where we're now selecting that data. If we go to group that data, we totally can, which would just be adding in that user agent, and then we can order it by that data as well, depending on how we see fit. Our results now will be slightly different than before, so we have to remember the way we are returning our data is going to play in right now. So event bucket schema, we need to make sure that we are using the label of UA. Make sure that that's in there as well. So the event schema here, we'll go ahead and bring it in as simply UA. This might have a, or not UI, but UA. This might have an optional value in here as well, which you just set to an empty string maybe. But we'll go ahead and save that. We'll save this, and then we'll go back into our list data here, and we'll run it again. And now what we see is these things being sort of collected together. And right now it's only showing one count for some of these different user agents. So realistically, this isn't that great because it's not really parsing the data the way I want to, because there's different versions and stuff. Well, if you want to get super granular, this is going to be great, but we don't want to get that granular. That's maybe too granular for us. So what we want to do is take it a little further, and we're going to change how we actually return back this data. So back into our routing here, what we can do is we can import another SQLAlchemy function here. So I'll come in and bring in something called case, and we can add in something called a operating system case. So inside of my read events now, I can come in here and say something like this, where we've got our event model, user agent, and then it basically says, hey, if it's one of these things, it's going to set it to something else, and then that's what it's going to end up being. Otherwise, it's going to just mark it as other. This now I can use as my user agent in here. The label I'll leave as operating system. So we'll go ahead and paste this in here. Then we will paste it here and here. So basically taking place of our original user agent, although it's still the user agent. Once again, I made some changes to the query, which will affect the results, which means that I need to update the schema itself, in which case I'll go ahead and copy the UA. This time I'm going to go ahead and add in the operating system in here. Same sort of idea, still optional. Let's go ahead and leave that as is. Operating system is the label, which is why I named it that way. We have all these other labels for that same exact reason. So there we go. We save it. Let's go back into our list view here, do a quick search, and now we've got a much better look at what this data could be. We've got Android at the home page, Android at the about page, how many times, when, all of that. And we can keep going through and really see very, very robust data. So this concept here, we could take even further, right? So we could use something like OS case to unpack different IP addresses so we can see the different parts of the world. We could do all sorts of that within the query. Now, I'm not going to go through those advanced queries in this one, but that is absolutely something you would be able to do at this point. But let's go ahead and take a look at how we might do the average duration. So I'm going to go ahead and copy the operating system thing here and go ahead and do AVG duration. This is going to be optional float. And then we'll go ahead and add in 0.00 or something like that, where it's an average duration value. Now back into our routing here, what we can do to add that average duration is just put it into our select. What you do that is func.avg, then you grab the average of what that value would end up being, which is the event model duration, and then you set a label to it, and it's average duration. And then there we go. So now we have enriched this data with the average duration. Everything else doesn't need to change because how we're grouping it together is going to be based off of that operating system and that page and the time, not the average duration. That wouldn't actually make any sense to group it by the average duration in this place. Okay, so now that we've got that, let's go ahead and take a look inside of our list here. If I do a quick search here, what I see is that average duration is coming through on each one of these. And what we should be able to do is actually modify that to, let's just modify how we were sending this data in the first place by going back into send data here. We're going to change the average duration up by a lot. I'll go ahead and say 50 to 5,000 seconds, which is definitely a much different look at the durations themselves, which should give us a different response back to the actual data that we're getting, depending on our duration parameter here. So if I said every 15 minutes for our duration, we run that, our average durations will hopefully change at least somewhat. Now, of course, there would be a bunch of ways on how we can modify this, but here's another average duration that just popped up a lot. That's because of that change that we just did. There was a chance that wouldn't have happened, but it's overall really nice that we're able to completely change how our analytics works, and we can do it in a very short amount of time. Now, this is where spending a bunch of time to build out more robust queries might be really useful. We now have the foundation in place for a very powerful analytics API where we control all of the data that's coming in and ignore the data we don't want. Then we can also analyze this data with our very own queries. Now, this data itself, the actual SQL data that's coming through, the table design, probably could be done in Postgres by itself. But the real question here is how efficient or how effective will it be as your data set grows a lot? And the answer is it won't be. The nice thing about Timescale is you can just add it whenever you need to. So if you want to start with just a SQL model, you totally can do that. Now, of course, the package that we went through won't necessarily automatically do that just yet. Maybe at some point it will, but right now it doesn't do that. You kind of have to decide this from the get-go in terms of this particular package. But in the long run, in terms of Timescale, you can add this at any time, and there's a lot of options for that, which is really nice, and it gives us a lot of flexibility. And the fact that it's open source means that we can just activate it in our Postgres database, and we're off to the races. But what we want to see now is we want to take this to the next level, which is actually deploying it so we can see it in production, what it might actually function like on our own systems. Let's take a look at how to do that in the next section. We're now going to deploy our application into production using Timescale Cloud and Railway. Now, Timescale Cloud itself will allow for us to use Timescale, but not worry about running Timescale. It's a managed version. So all of the performance gains, the new releases, the bug fixes, all of that stuff is going to be in the managed version, so we don't have to worry about it at all. Now, do keep in mind that Timescale is based on Postgres, so it's still just a Postgres database. So yeah, we could still use the open source version of Timescale if we want, but it will be a lot more simple if we just go and use Timescale Cloud directly. So go to this link right here so I get credit for it and they know that we should make some more videos covering all of these things. Then we're going to be deploying our containerized application into Railway. Now, we've already seen how to build out the containerized application, so this process is going to be fairly straightforward as well. So we'll be able to integrate the two of them and just have it run, and we'll test all of that in this section. Let's jump in. Before we go into production, I'm going to go ahead and add in some CORS middleware. This is cross-origin resource sharing. CORS allows us to prevent certain websites from accessing our API. This also means certain HTTP methods as well. Now, we're actually going to open up the floodgates on it, mostly because we can actually turn this app into a private networking resource. In other words, the other apps that would access it need to be inside of that same network that is deployed. Similar to like you can't access my version on my computer because it's in its own private network that you are not a part of. So that's kind of the same idea when we go into production. So for that reason, I'm going to go ahead and open up my CORS here. So we'll go ahead and do from fastapi.middleware.cors. We're going to import the CORS middleware. And then underneath the app here, I'm going to go ahead and do app.add middleware. And it's going to be our CORS middleware like this. And of course, you can go into the FastAPI documentation and get all of the different arguments you might put in here. In our case, we're going to allow all origins all methods, all headers. We're letting everything come through. But if you were going to expose this to the outside world, you might want to lock down the origins to like your actual website domain. You might only want to allow get and post methods in here, maybe not even delete, right? So that's something else that you can think about going forward. But this is one part that I wanted to make sure we had before we went into full production. So now what I'm going to do is I'm going to push this into GitHub. So what we've got here is in my terminal, I've got git status. I can actually see all of the files that have changed. Now, I'm actually not going to show you this process, mostly because I also have git remote-v. I actually have the entire code that you'll be able to use in the next part. We'll actually use this code directly, make a few changes so we can do the deployment directly. I won't do anything else inside of this project at this time other than just adding those cores, and that will be on GitHub in just a moment. Now what we'll do is take it from GitHub to deploy it. At this time, go ahead and log into GitHub or create an account if you don't already have one. This account that I'm using is really just for these tutorials. Then you're going to want to go to cfe.sh/GitHub. This will take you to the Coding for Entrepreneurs profile, in which case you'll go into the repositories here and you'll look for the Analytics API repository. Of course, do a quick search for it if you need to. It's going to be this one right here. Now, the point of this is really to just go ahead and fork this into your own project here. So you go ahead and create that fork and it's going to bring the code on over. Now, what we need to do is we need to add some additional configuration to our now forked project. Now, that additional configuration has everything to do with deploying FastAPI. So if you actually go to fastapicontainer.com, it's going to bring you to this, in which case will allow you to scroll on down and you can see the code directly that's going to be used here. Now, this code is just boilerplate code to deploy FastAPI into Railway. That's it. So in our case, we really just want this railway.json because it's something I've worked out to make sure it works really well for you. Now I'm going to go ahead and copy the contents of this, which you can, select all of it or just press this button right here. Then I'm going to go back into my repo, the one we just forked from the Coding for Entrepreneurs profile. Then we're going to go ahead and hit add file. We're going to create a new file here, and I'm going to call this railway.json, and I'm going to paste this on in here. Now, before I commit the changes, I will say that it would have been, or it will be, a good idea to have it on my local project as well. I'm just sort of assuming that you are not using Git or you haven't been this whole time. Maybe you don't know it yet. But of course, if you do know it, you know what to do from here. But the idea here is we need to adjust our Railway settings to ensure that this thing actually gets deployed. Now, what we see is this build command. This build command is looking for a Dockerfile that does not have a period. It just says Dockerfile. So we need to use Dockerfile.web because that's our actual Dockerfile path, which of course is going to be the same for our watch patterns. So we actually seen something like these watch patterns already. Compose.yaml has watch patterns. What do you know? Now we actually didn't update our compose.yaml very well. This one probably should say .web as well, but the point here is we want to actually rebuild this application based off of these patterns here, mostly for the SRC and requirements. Those are the main ones, of course, but Dockerfile is another one that's important as well. Then we also have this deploy stuff. This deploy stuff is looking for that health check. Do you remember when I said we will have a health check? Well, if we actually look in the main.py code and scroll on down, here's that health check right there. Notice there's not a trailing slash here, but on this one, it's looking for a trailing slash. Let's get rid of that trailing slash. We want to make it the same as what's in our code. So now that we've got this, I can go ahead and commit these changes, and we'll go ahead and say create railway.json. Great. Our code is now ready for Railway. There's not really much else we need to do to deploy it. So let's go ahead and actually do that. Going to railway.com, feel free to sign up for a free account. Jump into the dashboard. Notice that I'm on the hobby account. This is a key part of this. We're going to go ahead and jump on over into our account settings, and we want to make sure that our account integrations are connected to GitHub. So go through that process if you haven't. What you'll end up seeing is something similar to this when you go through it, and then it's going to say, hey, what repositories do you want? You could say all of them, or you could select the one that you just forked, which is what I'm going to do. Obviously, I have two in here, but I definitely want to have the one I just forked. So I'll go ahead and save that in here so that now I can go back into Railway and I can deploy this. So let's go ahead and do new now, and notice that the Analytics API is there. It's ready to go. It's ready for me to deploy it, which is really cool. It's a very straightforward process in terms of the deployment. But the key here is we want to look at our settings. Inside of these settings, we should be able to scroll on down, and we should see the builder that it says build with a Dockerfile using BuildKit. Mostly that it says Dockerfile.web in there. If yours does not say that, that most likely means that your railway.json in here is done incorrectly, which might mean that that isn't correct. That's kind of the idea. Beyond that, we actually probably won't need to change anything much. Notice that it has watch paths in there as well. We should not have a custom start command. That's not necessary. One of the things we might need to change is the actual region, but I'll stick with this region for right now. And then if you scroll on down, notice the health checks in there, the timeouts in there, all of this stuff is in here. Things are looking pretty good. Okay, great. So what it actually does is it automatically starts deploying. This might deploy, it might not. I actually think it would fail, mostly because we don't actually have our database yet. So let's go ahead and start spinning up our database, and let's combine the two in here. Assuming that you've already signed up for Timescale Cloud, you'll log in and you'll see something like this. We're going to go ahead and create our first database service right now. So the idea, of course, is we're using Postgres, so we can just go ahead and hit save and continue. Now we can select what region we want to use. Now, the region you end up using will likely be close to you physically or close to where the most of your users are. So if you're doing this for someone else, you're going to want to put it in that region itself. Now, US West Oregon is the closest to me physically, but it's also the closest to where I actually have my app being deployed on Railway. So if I come in here into my settings, I can see the deployment is in California. Now, there is one for Oregon in here as well, so I could always change that too. Now, that deployment is going to fail as well, but I'm going to go ahead and leave it in as Oregon because inside of Timescale, I have the ability to use Oregon as well. So now I'm going to go ahead and hit save and continue. How much data I'm going to be using is practically none because we're still early days. We're going to use development here, and then we're going to go ahead and hit save and continue, and then we're going to create the service, and I'm just going to call the service name Analytics API, and then we're going to go ahead and hit create service. Now, we get a free trial here for 30 days, which after that free trial, it's still very affordable in terms of the ability, what we can do in here. But notice we get a new connection string. So I'm going to go ahead and copy this connection string, and I'm going to bring it locally first. So in my .env down here, I'm going to go ahead and say prod db URL, and I'm going to paste that in. Now, the reason I did this is twofold. Number one, if I ever want to test my production URL locally, I totally can. Now, this also means that if you skipped using Docker Compose, this is the route you could do, but then you would also use something like this where you actually change the connection string just slightly. So realistically, you would use something like that. You would actually comment out this old one and then use this new one. Now, in my case, I'm going to leave it as is, and I'm going to go ahead and copy the entire new string with it commented out. Now I'll go ahead and jump back into Railway, into variables here, and I can do this raw editor and just paste in those key value pairs, right? That's it. And then I'm also going to go ahead and update those variables. As soon as I do that, it's going to attempt to deploy, which I'll go ahead and let it do. Now, one other thing that's important to note is how this is being deployed, how it's going to be run. So if we go back into our project a long time ago, we created this Docker run file, which has a run port and a host. So this run port is going to either be set by us or by Railway. So we could set this port in here. So inside of our variables here, we could come in and do a new variable, and we can set it to whatever we would want. I'm going to use 8080, which I believe is the default on Railway, but I'm going to go ahead and set that port in there as well, and then we'll go ahead and deploy that one as well. So one of the nice things about Railway is the ability to really quickly change your environment variables, and then it will go ahead and build those containers for us and then run them for us. Very, very similar to what we were doing with Docker Compose in that sense. Now we also have this run host here. Now at some point in the future, we might end up using this a little bit differently. So at some point, if you want a private access one, you might need to put your run host, the actual host itself, inside of a variable as this value right here. So you would do something along the lines of run host equals to that. in which case I will go ahead and put this into my sample.env, compose file here, just so we have it for later. But that might be something if you don't want to expose this to the outside world. Okay, so after I did all those changes, in a matter of minutes, it was able to deploy the application itself, and we can view the logs and deploy logs. This will show us that it is running, and notice the port in there says 8080. We also have our build logs in here. We could go through this. This is building the container for us. It happened really quickly, and then it did the health check, which also happened really quickly, and then of course it finally deployed. So now what we can do is, since it is fully deployed, we need to of course access this API itself. So inside of our settings here, we go into networking, we generate a custom domain. Now, sometimes it might ask you what port you want to use, sometimes it might not. In this case, it just defaulted to the environment variable port that we have. We might even be able to edit that. It looks like we can right in there, which is really nice as well. So the one thing that I want to check though is, before I go any further, is making sure that the deployment is in that region that I wanted. And sure enough, it is. Great. So going back into our networking, this is our API now. This is the actual URL that we can use. And here's that hello world. And of course, if I go into /API events, the actual endpoint itself, we should have no events, which is very, very straightforward. So if you are a casual viewer, you will notice now this is a production deployment. It's fully production. And it's also using, of course, Timescale. If we go back into our Timescale service here and go to the service overview, we should see that it has been created, right? So we've got service information in here. We can see all of the things related to it by doing our Explorer in here. We can see that there is a Hypertable, and what do you know? There's that event model. All of that is working really well. Now, of course, we could always open up PopSQL and bring in that cloud-based version as well, which of course is one of the things it's built for, and you could always test things out there. You could also do all of this stuff locally as well, like we discussed. Okay, so what we really need to do though is we need to test this endpoint, the actual production endpoint, and see if it's working and how well it's working. Let's take a look. Let's go ahead and send some test data to our production endpoint. So what I'm going to do here is I'm going to copy the actual URL that I got, which of course came directly from Railway. It's this URL here. Of course, you could always have a custom domain as well, but I'm going to go ahead and use the one that they gave us. And then I'm going to jump into my local notebook here where it says send data to the API. And I'm just going to go ahead and change our base URL to that exact value. Now, I don't actually want the trailing stuff in here. I just want to make sure that I'm using HTTPS and then the actual endpoint that it gave us. Always use HTTPS if you can. So now that I've got this, I should be able to send out a bunch of data. This one right here is not actually valid anymore. We want to use the new data that we have based off of the new schemas that we set up and all the new models. So here it is right here. I'm going to go ahead and run it. It is 10,000 events. So in theory, it should be able to send all of that data just fine. It looks like it's working fine. Now, if I go into the production endpoint itself, refresh in here, there's some of that data. It is now working, and it's working in a way that hopefully you have expected. Now, this of course is now a production endpoint. It is fully ready. You are ready to deploy this all over the world if you want to, and have it in all of your applications and just go wild with analytics. But there's still one more thing that I want to show you, and that is how to use this privately. Now, of course, we could always sit here and wait for all of this to finish and have all of that data to come through. I'll let you play around with that at this point, but let's actually take a look at how we could deploy the Analytics API as a private service so we can still use it this way, but just not expose it to the outside world. Now, it probably comes as no surprise that you don't want to have your Analytics API open to the outside world, because then you might get events that aren't accurate. They're not real. So of course, we need to change that. We need to turn our Analytics API into a private networking service only. So you can have private networking in a lot of cloud services. What we're doing here is we're really just removing the ability to have public networking, which in the case of Railway, we can just delete the actual endpoint itself, and now there's no public networking whatsoever. But there is private networking, and this is something that's done by default. In the case of Railway, you have to use IPv6, which means that we need to update how we access this. Now, we could spend a lot of time on FastAPI itself to harden the system, add security layers to allow only certain connections. But as soon as we turn it into a private networking thing, it just adds a whole layer of security right there. So we don't have to necessarily add all this additional stuff into our application. So what we need to do though is we need to modify our Docker run command here, and that's going to be by changing the host. I think I mentioned before that it was the run host, but it's actually the host in here that we need to change, and we need to change it to being this right here. So that's what we're going to do now is we're going to do host equals to that as our environment variable, and it has to be these two brackets here. This is how gUnicorn is able to bind to IPv6. So IPv6 is that. By default, it's IPv4, which is what this is right here. So let's go ahead and grab this, and we're going to go ahead and bring it into our analytics API as a variable. We're going to go ahead and bring it in here just like this. Go ahead and update it and deploy it. Now, there's a chance that this won't work. The reason that it might not work has to do with how this string is here. It's possible that this needed string substitution, which we'll see in just a little bit. It's also possible that it worked just fine. So once again, we will see that in a little bit as well. Now, it's one thing to make it private, and it's another thing to make it private and still being able to access it. So the thing about Railway that makes it a little bit simpler is if we go into the settings on our application, we can scroll on down to private networking, and here is the new API endpoint that we can use inside of our Railway deployments. The big question is going to be, how do we access that without building out a whole nother application? I'm going to show you that in a moment. So what we see on our API though is that it looks like it's being deployed and it looks like we're in good shape. Let's look at our logs here, more specifically our deploy logs. It looks like it's listening at that actual location. So that's actually really good. Everything else isn't arrowing out. We do see those print statements. That's a good sign. So now we actually want to deploy something that will allow for us to test out these communications. So I actually created a tool called JupyterContainer.com, which will take you to this right here, which allows you to have a Jupyter notebook in a server right inside of Railway in your own environment. So the way we deploy this is by going back into Railway, hit create into our project here. So the important part of this is you are in the exact same project that you've been working on. Notice that I have a couple deleted in here. This one I want to go in and I want to use it right next to the Analytics API. I do not want to deploy a new project, which may happen if you just go to Jupyter Container and deploy it directly from there. So what we want to do then is come back into our application here. We're going to go ahead and create, go into template, look for Jupyter, that's with a PY, and Jupyter Container. You could probably use Jupyter Lab as well. Jupyter Container works because I know it works. That's pretty much it. Okay, so the next thing is we want to add in a password here. I'm just going to do ABC123. That's going to be a password. This is going to be publicly accessible, as we'll see in a moment. I'm going to go ahead and deploy this, which might take a moment as well. So it's going to also have a volume on here for persistent storage, which is actually kind of nice when it comes to wanting to use things. Okay, so the next thing here is though going to be our variables. Now what I can do is I can add a variable to my Jupyter container that references this Analytics API variable. So let's go ahead and do that. I'm going to go ahead and hit new variable here, and I'll go ahead and say, let's go ahead and call it Analytics Endpoint, something like that. And then this one I'm going to use $, 2 curly brackets, and I'll type out Analytics API, and these are going to be the objects that we have, and that's going to be specifically the Railway private domain here. So that's the one that I want to have access to inside of this container, which kind of connects them together. So I'm going to go ahead and add that, and we'll go ahead and deploy it. Now these deployments do take a little bit of time because it is building a container and then it's deploying the image based off of whatever is going on. But one of the main things here is as soon as I create that variable, a line is created here showing that they are connected in terms of Railway. This is important because the actual Jupyter container itself should have a public endpoint, as we see right here. So it already has one as far as the template is concerned without us doing anything else. So that's really my goal with this Analytics API, is to have it so easy that we can deploy it pretty much anywhere we need to, as long as we have the necessary configuration across the board, which of course would include our TimescaleDB in there as well. So now what we want to do is just wait for this to finish so that we can log in to our service once it's up and ready, which we'll come back to. Okay, so the Jupyter container finished after a couple minutes. Let's go ahead and jump into the actual URL for it. There it is. I did ABC123 to log in. Of course, if you forgot what that value was, you can always go into your variables here and just look for this Jupyter password. This container is meant to be destroyed almost as soon as you open it up. So you can delete it at any time is the point. So going back into that Jupyter notebook here, what we can do is we can jump into the volume and I can create a brand new notebook in here. And we're going to call this, connect to analytics or something like that. I'll just call it connect to API. Now I'm going to go ahead and import OS here. If you're not familiar with Jupyter notebooks, well, you probably are now. All of these NBS here, these are all Jupyter notebooks. They're just running inside of our cursor application. So what I can do is I can use os.environ.get, and I should be able to print out the environment variable that we used for our analytics API endpoint. So I'm going to go ahead and do that, and there it is right there. Notice there's no HTTP on there, so that's an important part of this as well. So now what I want to do is import something called HTTPX. HTTPX is basically like Python requests, but it allows us to call the IPv6 endpoints themselves. So our actual endpoint, our base URL, is going to be equal to http:// this value right here, which I'll go ahead and set up here like this and just do a little magic here. Not really magic, but we'll go ahead and do some string substitution. There's our base URL. Let's jump back into our send data to the API thing in here, which I'm going to go ahead and copy this whole thing. And we're going to go ahead and bring it into our Jupyter notebook, paste it in like that. Now I don't have Faker in here, I don't think, so I'm going to go ahead and install it. So that installation is going to be a matter of pip install Faker. And that should actually install it onto the Jupyter notebook itself. And then we should be able to run this. Now, of course, the base URL here is now this one. So I can go ahead and get rid of these two right here. And I also want to use HTTPX, not using Python requests. So there's going to be HTTPX. And I think the API otherwise is basically the same. Let's go ahead and give it a quick little run. And we get an error in here for that one. No service known in here. So that's a little bit of an issue that we will have to address. Before I do though, I want to just take a look at the base URL, and what do you know? I didn't do some string substitution. So let's go ahead and make sure we do the string substitution as one would so that we have the correct base URL. Now I'm going to go ahead and run this, and it still might fail. Now, the reason it still might fail has to do with the port value. We've got connection refused. So when we actually deployed the public endpoint in here, when we went through that process, it asked for that port value. So this is why I actually mentioned it in the first place, and so that we can understand that we do need to know the port value. Now you could go through the same process as the Analytics API endpoint. I already know what the port value is off the top of my head, and it's 8080. So that's the one we are going to go ahead and use, and we want to use that port right here. This would be the same thing as if we were doing this locally as well. And so now we should be able to see this same base URL. I'm hoping this actually solves the problem. It's certainly possible that it still won't solve the problem. But of course, if we look into our deployment for this Analytics API, we should see that it is running at that specific port. This is the endpoint right here. So instead of using whatever this is right here, right, we are using the actual private IP address name, basically, which is this right here. Okay, or a DNS name, rather. Okay, so now that we've got that, let's go ahead and see if it starts to work. It looks like we've got no response of OK, so HTTPX doesn't do the same thing. Let's go ahead and actually just print out the data. I'm going to go ahead and come back here and get rid of that, and we'll just go ahead and run this. There's that data coming back, and it's quite literally working in a private networking setting. Pretty awesome if you ask me. So the other part about this, of course, is to verify this data. I'm going to go ahead and stop this. We don't need to add in 10,000 things. We can just do 10, for example. We could also just use the get command to grab that data as well. So I'm going to go ahead and grab this response, similar thing. It's going to be the create endpoint still because it's the same endpoint to do .get, and then we can get that data back and we can see what it looks like. By just like that, we'll get rid of some of these comments, run that, and there you go. We now have that data coming through as well. Now, of course, if we were to change the params, let's go ahead and change that. In the case of the duration, I think it was, we'll go ahead and say 1 day, and that's all I'll change. And now the data is going to be a bit different, right? And we can also change the pages. Let's go ahead and do that. I'll come in here and say pages, and we'll go ahead and put in maybe just the, let's go ahead and do just the pricing page. And we'll see what that looks like. And now it's only doing the pricing data in there, which is not nearly as many because, well, it's going through 1 day, which is grabbing different operating systems over that day, right? So we saw that as well. But the point here is we now have a private analytics API that is well deployed and leveraging a lot of cool technology. To wrap up this section, we are going to want to unload everything that we just did, as in delete all of the deployed resources, unless of course you intend to keep them. In the case of Timescale, we're going to come in here and just grab delete service, and then we're going to go ahead and write out delete, go ahead and delete that service. That of course will delete all of the data that went with it, which of course is no big deal because we did a bunch of fake data. We also want to jump into Railway itself and delete the entire project, which we can do by coming in here, whatever that project is, you go into settings, you go into danger, and then you can remove each one of these items by typing out their names. This, of course, is just to make sure that you clean up all the resources you might not be using in the future. So I'm going to go ahead and delete both of these, and there we go. And then I'll go ahead and delete the project, which I think would also delete those other services. But this process has changed a little bit since the last time I did it. The idea here is we've got all of these things being deleted, including the services we were just working on. So at this time, I won't be able to access that Jupyter Notebook at all any longer, or our deployed production API endpoint. But you now have the skills to be able to deploy it again and again and again because, well, the repo is now, of course, open source on github.com. So feel free to go ahead and deploy your own analytics API. And if you do change it and make it more robust than what we have here, I would love to check it out. Let me know. Hey, thanks so much for watching. Hopefully you got a lot out of this. Now, I will say that data analytics, I think, is going to get only more valuable as it's going to be harder and harder to compete. So it's one of those things that I think I'm going to spend a lot more time in. What I want to do next is really just kind of visualize the data we built. I want to build out a dashboard, and I encourage you to attempt to do the same thing. After I have that dashboard, I really want to see how I can integrate it with an AI agent to see if I can communicate or have some chats about the analytics that's going on. But before I can even make use of chats or a dashboard, I probably want to use this somewhere for real so those things are actually better and will help me make decisions. Either way, it's going to be an interesting technical problem, and we'll probably learn a lot, and I hope to show you some of this stuff in the near future. So thanks to Timescale for partnering with me on this one, and thanks again for watching. I hope to see you again. Take care.